Okay, we're back, I think. Let me double check. Test. That's working. Test. That's working. Let me post that I had to restart everything. Okay. There we go. All right. Now, let me make sure this doesn't ever happen again. We're gonna go here. I gotta add the screen the right way. It wasn't showing stuff. It wasn't showing the things I wanted it to show. It was showing things I didn't want to show actually. So let's remove that. Okay, let's add a new one. Let's have this as the display capture, and let's call this far right monitor add. No. Yes. Okay. Let's move that like that. Put the webcam above it. Put the custom message above it. There we go. Okay, so now we can minimize this one. And let's go grab one of Phoebus's videos, because we're pretty much done with that one. Videos for live streaming. Let's check out the reinforcement learning. There we go.
So we're going to look at...
Now, there's got to be a better way to do this than just showing the whole monitor. Let me try something different. Window capture? What happens if I add browser? Oh no, that's just putting in the thing. Display capture maybe. Window capture. Let's do let's add that one. And what I'll need to do is remember to open a new tab. Switch this over to that new tab. Yeah. Okay, let's get rid of this one. There we go. That seems good. Let's make it a little bit bigger, bigger. Here. There we go. Let's move this guy over here. Move that thing up there. Okay, that's working. And we hide that. Okay. Perfect. Okay, let's try this again.
How to use an AI technique called reinforcement learning to solve the same kind of decision problems we saw in previous videos.
Okay, so this is the monster commute to work.
The monster commute to work. And really, reinforcement learning, you can think about this is how people might do it in practice. Reinforcement learning is a key area of machine learning. There's like 3 types of machine learning. You've got supervised machine learning, where someone tells you the right answer and you use that to make your system better. Unsupervised, where you don't really know what the answers are. You just you sort of structure the data. Reinforcement learning, you don't get told what the right answer is, but you get some signal, typically a reward, that tells you how good the action choice you made or how good the answer was.
How well you did.
How well you did, yeah. It's like a pat on the back, 2 pats on the back, 10 pats on the back, things like that.
Oh, fantastic.
Or in our commute example, it's like looking at your watch and going, oh, I was on time, I arrived in this amount of time. So in our commute example, the time taken is your reward signal. And we've been kind of minimizing costs, but in reinforcement learning, people typically talk about maximizing rewards. So we can just think about like the negative of our costs, but put a minus.
Or how early you are for
How
work.
early we are for work. Perfect. That's what we're trying to maximize, how early we are for work. And this is actually similar to the Monte Carlo tree search world, in that reinforcement learning not only doesn't assume a model, well, let's just say reinforcement learning doesn't assume a model. So we're going to have to learn the probabilities or learn the transitions as we go, and we're going to have to learn the values. And the difference between what we saw in Monte Carlo tree search and what we have in reinforcement learning is the assumption underpinning reinforcement learning is we don't even have a simulator. So we can't think before we act. All we can do is act in the world and get these rewards back and use those rewards to change how we act in the future. Okay. So the original idea of reinforcement learning is it's always online. And instead of thinking, we just act and then we use the results and get better.
I'm hoping they're not using this for self-driving cars then.
Well, reinforcement learning is used for self-driving cars, but that's actually the interesting caveat. So in robotics and actually in a lot of problem solving, you can use reinforcement learning as an offline solution technique if you don't have the model and you're trying to build a policy, particularly with a neural network or some complex internal representation for very, very difficult problems. So those kind of difficult problems are problems where instead of our state being I am at home, that state might be a camera image or all the positions of robot joints. And you can use neural networks and deep learning to turn those into states you can reason about. But we're not going to talk about that. I'm lovely and happy in my simple commute world with what we'd call discrete states and actions. So these are single discrete separable states and actions, and we can count them, we can enumerate them. And so this is typically almost a toy problem for reinforcement learning. But we'd call it tabular. And that's because we could write a table of all our Q values or a table of all our state values. And the way we write the cost of an action is something called the Q function. And the Q function is the action cost or the state action cost. And so tabular reinforcement learning is where reinforcement learning started. And we can use that just to understand what happens. So probably the most famous picture in reinforcement learning, and this might be all we draw today, is you've got some agent, and that agent has a policy, pi, and it uses that policy to choose an action. That action gets executed in the environment. Oh, running out of space, environment. And this environment tells the agent, okay, you've now changed state, and you got some reward for executing that action. So agent picks an action, and the environment executes that action, or the agent does the action in the environment, and then the agent gets told what the next state is and what the reward is. So there's no model, no simulator, we only have the environment. In robotics, actually, we might actually replace the environment with a simulator, and then later on try and use that policy in the real world. That's called sim-to-real transfer, and it's one of the many open problems in this kind of area. This is the basic setup. So the way to think about this learning is with this commute example. Every day you wake up, you've got to go to work, you ask your policy, what should I do? You follow the policy, you choose an action, maybe you get in the car, the environment tells you, oh, now you're in medium traffic, you drive to work, you get your rewards at each time step of how much time did I take in each step. And at the end of the day, you've written all that down, and you work out how late I was and give yourself a reward based on that. And then the next day, you look at your notebook and go, oh, well, that was a good choice. I wasn't very late, so maybe I'll try that again. Mm-hmm. And that's how this is going to work. We're just going to keep track of the rewards we get in each sort of trajectory of states. So a trajectory will be the sequence, and we're going to use that to calculate changes to our policy that tell us to prefer one action or another over time.
Okay, so I'm imagining being 10 minutes early for work, so I treat myself to a coffee and a donut. Right?
That's your reward, yeah.
20 minutes early, I have 2 donuts. Right?
Yeah. Or maybe the glow on your boss's face is all you require. But the underpinning maths, which we're not really going to go into, is really just the same as the maths we saw for Monte Carlo tree search and the maths we saw for value iteration. There are Bellman equations, and we're going to use sample averages in those from the data we get from acting in the real world to work out to solve the Bellman equations. Basically, we're going to compute Q values for each action, and then our policy is going to be the policy that minimizes Q values, and more or less we're going to try and minimize the expected value. So very similar to Monte Carlo tree search, but now we don't get to think in advance about all the possible options. We only have our policy that tells us what to do. The first couple of times I do this, different actions will have different values, and I don't know, is that the right value or not?
So it might be that you accidentally happen upon something that's very rare and you end up, that affects everything else.
Yeah, you need to even try that potential rare thing. So you need to either explore or exploit. That's the answer I was looking for, Sean.
Sorry.
So we have this, we have explore versus exploit. We might as well write that again, because it's kind of key. So we still have exploration versus exploitation. And this is even really a bigger deal in reinforcement learning. If you assume that this is in its kind of fundamental kind of way of doing it, where you're literally every day you're acting, if all you're doing is trying random ways of getting to work every day, your average time to get to work is going to be very, very high. You're going to be very slow. So if you're, inventing new forms of transport, going by hot air balloon, right, that's not going to be very sort of...
Image of a jet ski down the canal in my head, I don't know why.
Perfect. But that's probably quite an efficient way to get to work in Oxford, at least. So yeah, if you're exploring all the time, you find lots of good options, but then like your average time is going to be very poor because some of those are going to be very bad. Exploitation means when I found a good option, I need to take it more often. So here we're going to think about just more often taking good actions, and that's what the Monte Carlo tree search approach was doing as well within the tree. Here we want to do it within the real world, but because we don't have that tree structure, maybe the only thing to think about in this example is we need to change our policy. So our policy is what's selecting the actions, and the thing that we do in reinforcement learning quite typically is we make something called an epsilon greedy policy. The idea of the mass here is that with 1 minus epsilon, you exploit, otherwise you explore. So you can you do epsilon over the number of actions you've got, and that's kind of the probability per action. So you take the best action with this probability, you choose one of all of the other actions with this probability. And typically epsilon is small, like less than 0.1, maybe less than 0.01. But this is what's going to allow you to balance exploration versus exploitation. The kind of really basic idea of reinforcement learning is you've got this policy that's going to choose different things every day, and your job is to actually work out what the best action is, and that will come from Q values again. So the best action is going to be the one, in this case, that's going to maximize your Q value, because we're talking about reward now. Previously, we were talking about cost. And then that's the action, the max Q action is the one that gets taken with 1 minus epsilon, and then we try something else otherwise. Like, we don't need to go into all of the maths about how this works, but you can just maybe think about, just like run through one very quick example of our commute action. And what we do is we're going to get some trajectory. So I talked about state trajectories, and that's what the reinforcement learning kind of runs on. So I'm in some state at time t, I take some action at time t, and at time t plus 1, I get a reward. I also get to see the next state, and then I take my next action until the end of time, potentially. And so we have this trajectory of state, action, reward, state, action, reward. So if we go to our example, so I'm at home, and then my policy says take some action. We might think about the train. Well, no, let's do car, because I think train, we might get ourselves into these infinite loops and the video never ends. So I choose the car, so that's my choice. I get my immediate reward, which was the reward of going to the car. So that can be -1, so we're just going to stick a minus in front to make all our cost rewards. And then the next state is chosen by the environment. So that might be medium traffic. That's the most likely one. Then I've got my action drive. I get my reward of -20. And then it takes me to the next state, which is work, and I'm done. That's the trajectory. And in the simplest form of reinforcement learning, something called Monte Carlo control, so this is another Monte Carlo algorithm, all we're going to do is kind of work backwards and work out, well, the drive action, in this case, the Q value of drive is -20, and the Q value of car in these states is -21, because I'm going to add, right, which is -20 and -1. And the value of home is going to be the action which maximizes the Q value over the choices we've got, which we know turns out to be car in the end. And we do this a bunch of times. So this is a Monte Carlo algorithm. And what we do each time, well, this one will never change. This might be -20, but say we hit medium on another trajectory, and then we hit high. Well, these are going to have, this will have a -20 down here somewhere, high will have a -70. And then when we're computing the Q value for the car, all we're doing is literally looking at -21, -21, -71, and then we just take the average of those to give us our Q value. So we're really just averaging what we'd call the return. So the return is the reward from here on out. So the return you often represent with G, which is like, how much reward do I get from executing this action and going on to the future? So you can think of that a bit like the value. This kind of approach is very similar to the kind of Monte Carlo averaging we saw in the tree for Monte Carlo tree search, except now we're doing this in the real world, right? So we're trying to do this over time, and you'll see all the values kind of converge to the values we knew from the previous videos. There's one problem with this method, and that motivates a whole bunch of other stuff in reinforcement learning. So we use this epsilon greedy policy because that forces the exploration. But the problem we've got is our policy that we're executing in the real world is always epsilon greedy. So even if I've been computing to work for 10 years, one time out of 10, I'm going to pick some random action. And that in some sense is healthy because it allows you to explore different options. But it also is ineffective. If the cost of all these different options doesn't change, then being forced to explore one time in 10 or whatever is kind of a waste of time.
Doesn't really have any effect on the, yeah.
Well, no, it does have an effect. It makes you late for work, like one day every 2 weeks. Okay. So it has an effect, because this is reinforcement learning. We're doing this in the real world, but it's not going to give you any more information. And so there's a bunch of other algorithms that do what's called off-policy RL, which will work around that. This is something called on-policy. There's huge numbers of videos you could think about those. And there's a bunch of different algorithms for kind of managing this data in a different way, learning in different ways. In our example, we assumed that actually this kind of assumes we've got a finite trajectory because we're working back from the end of the trajectory, summing these rewards. But you can also assume infinite length trajectories, and then you can just look at kind of the next step and how much better you got. There's something called temporal difference learning that starts to look into that area. But these are all just kind of lots of variations that people get very excited about and are used in robots and all sorts of cool places, but probably enough detail for today on the basic algorithms. So yeah, maybe the takeaway is this is how you might think about people doing it in the real world. They experience things and then they're kind of making judgments based on what they've experienced, and occasionally they might try something new.
This episode's brought to you by Brilliant, makers of fantastic courses and content like the stuff you're seeing on screen right now. They've got all the math and science, of course, and lately they've really been upping their game with computer science and AI. Just have a look. As you can see...
Okay, we're gonna move on. Oh, Computer File is a good channel. Really like Computer File. What else is Phoebus giving us here? Rust versus Go versus TypeScript. Which backend language is okay? Not that I know much about backend stuff. So this will be a good review. Ooh, this is a long one. Python's
Welcome
role
back.
And limitations in back-end engineering. Okay, this will be good. It's always good to understand the limitations of things.
To the Free Code Camp podcast, your source for raw, unedited interviews with developers. Today, we're talking with Ty Groot. He's a back-end software engineer, and he runs an open source project used by companies like Google. For the first half of the interview, we talk about back-end programming languages like Go, Rust, and TypeScript. Then Ty shares tips for learning back-end development and running your own developer consultancy. Ty Groot, welcome to the Free Code Camp podcast.
Thanks for having me.
Yeah, and it's a sunny day there in Northern California, where you're based, near the software development mecca, somewhere between San Jose and San Francisco. And we're thrilled to have you here on the podcast.
Well, don't dox the guy.
Yeah, thanks for having me. It's exciting.
Yeah, well, I want to start with a question. You're a back-end engineer primarily. I mean, you could do everything, but like that's where you've chosen to specialize for the past few years. And a lot of people, when they're doing back-end development, they may be thinking, oh, I'll just use Python. I mean, you can use Python for everything, right? Why not just use Python for everything?
Yeah, it's a great question. So I did just publish a course that talks about the relative strengths of Go and TypeScript versus Rust. Python's another one of those options, right? So Python was actually one of my first backend languages, and it was a good time. I like Python better now than I did back when I used it, but yeah, I mean, there's plenty of reasons. Let's get into it. So Python is fine as like a glue language, I think. I would recommend it to a lot of people, depending on the situation. Tends to struggle with loops. So people that are learning Python for the first time, or people that are evaluating Python as like a main language, may not realize just how much slower Python is compared to a compiled language. And sometimes that trade-off is fine, right? Sometimes getting the ability to run through something like a Jupyter Notebook kernel, and being able to execute code top to bottom and then pause it, and then have the ability to like fork your state and replace everything as is, and make small little tweaks and changes and keep everything kind of frozen in memory and work off of like a snapshot of the heap. Sometimes that can be way more important than speed. So an example where that comes into mind is, machine learning, right? When you're doing machine learning and you're testing something out for the first time, and maybe it took you 2 or 3 weeks of crunching numbers to get to the point where you are now, and you need to do an experiment. In Python, you can literally set a breakpoint and pause the execution of the entire interpreter. You can dump everything to the disk and restore later using something like it's a pickle and shelve, I think, are the two that most people use. You can do all sorts of like really nice things. The developer ergonomics on Python have gotten a lot better than they have been back when I was using it. Things like type annotations, and yeah. Python's come a long way. I started using Python, I believe, back on Python 2.7, and I only ever ended up moving away from Python because the roles that I had were primarily Go roles. So Go was like the new kid on the block. I've been hearing about it for a while. I mean, relatively speaking, it wasn't that new, but it's.
Yeah, Go is like a programming language, I think, developed by Google for like high concurrency and just like being really performant, is my understanding. That was like the primary thing that they optimized for. Is that accurate?
Yeah. So Go is a compiled language. So there's the runtime overhead is relatively low. Now it still is multi-threaded, and it has a garbage collector. And when I say multi-threaded, there's both threads and something that they have internally called Go routines, which are more like green threads. So your program may only be quote unquote single threaded, but you'll still have like a secondary operating system thread for running garbage collection and other things like that. So Go at least, the official statement is that Go was initially developed while a C++ code base was compiling. Like it was 100% of the Go original, 1.0 or the early tag release of Go was developed like while the developers at Google were waiting on downtime for a C++ code base to compile. I think it was Chromium or something.
Okay, so just to put that in context, so for people that have just been working with high-level scripting languages and just taken for granted that they don't need to have a compile step before they can actually see whether their code works. All right, they could just run it real quick. You can see there's I think it's like an XKCD where they're playing swords on the swivel chairs. Code's compiling. Their boss comes by. Why are you goofing off? Oh, the code's compiling. We can't do anything. I guess I'll just have to sword fight because the code's compiling. We're blocked. But so in the time that their code base was compiling, they were like, okay, let's switch your context and let's go develop an entire different programming language because we have time while this slow compilation process unfolds. So that's what you're telling me.
Yeah. So I mean, let's talk a little bit more about that if you want. We can talk about the just-in-time compilation, which so all code is compiled before it is run, right? So Python being an interpreted language, there's no traditional compile step where you take Python code and turn it into an executable that a .exe or nothing runnable that you'd install on Mac OS or Linux as well. But every line is being compiled. And then there's some caching and other dynamics you can get into, but every line is being compiled basically as it's being run, like compile and then run, compile and run, compile and run. So it seems almost faster to just run Python, script.py and have it just execute almost immediately instead of having a compile step ahead of time. But that slowness of the compilation is happening line by line as it's running. So in some sense, you could kind of say for a small enough Python script, it's actually faster to run Python than to build a massive Go program or C++ program. Because funny enough, you're kind of taking advantage of multi-threading almost, where you've got a core that's busy running the Python interpreter, which is the just-in-time compilation step, and then another one that's actually running whatever C++ modules that Python is gluing together. Because that's another big point, is that most of the time when you have useful Python, you're not actually just running Python, you're running some sort of pre-compiled C++ object that's already been built for you. Whether that's a web browser controller using something like I think it's Puppeteer or Beautiful Soup, all these different libraries, especially anything that involves encryption or TLS, anything that's hitting a web server, you're always going to be running some sort of pre-compiled C++ object under the hood.
Yeah. Support for this podcast comes from a grant from Wix Studio. Wix Studio provides developers tools to rapidly build websites with everything out of the box, then extend, replace, and break boundaries with code. Learn more at wixstudio.com. Support also comes from the 11,189 kind folks who support Free Code Camp through a monthly donation. You can join these chill human beings and help our charity's mission by going to donate.freecodecamp.org. And it's worth noting that Python itself and most scripting languages are originally if you go down far enough, it's C++, and below that it's C.
Yep.
And so what you're saying, if I can recap, this is actually new to me. I didn't realize this. So with an interpreting programming language like Python, it's essentially going in and compiling line by line so that you can skip that big upfront compilation step. It's just in time compiling. So if you have a small Python script that's only a few lines long, well, only those lines need to get compiled in because you're able to take advantage of the multi-threaded nature of some of the underlying layers of abstraction. It can actually be faster for a small Python program. The fact that
it's gotta be really small.
Yeah.
Yeah.
But the moment that your Python project gets bigger than maybe a few little files, a few little scripts that you're running, you do start to pay that penalty for having just-in-time compilation as opposed to having a compile step that you get with something like Go or something like Rust.
Yeah, and you'll see something very similar to that in JavaScript as well. So JavaScript is another interpreted language, famously so, right? It's the one that everyone uses for the browser. We've got WASM and a couple other things that are kind of emerging, but
Yeah,
we'll never get away
WebAssembly.
from Java's. Yeah, WebAssembly. Sorry.
Sorry, no, so it's okay. I didn't mean to interrupt you. I just love to share.
Yeah.
You know, whenever somebody hears a term or an acronym, they may be familiar with WebAssembly and not know what WASM is.
Yeah. So I mean, WebAssembly is emerging, but even WebAssembly requires like a JavaScript shim to get running. Like you have to inject it and start the runtime and pass data to and from the WASM or WebAssembly runtime. So we're never going to get away from JavaScript there. But so yeah, I mean, JavaScript being another interpreted language has something similar going on, right? So V8 is the most popular JavaScript engine, developed
Yeah, it's the
by
Google,
Google.
Chrome kind of.
Yeah,
How would you describe it?
yeah, it's the JavaScript engine and runtime that's most people will see it bundled into Chrome, but it's also what powers Node.js,
Right.
and a couple other things. So JavaScript has a couple of different modes of running, I guess. And so when you start interpreting a large JavaScript code base, it will just get basically JIT compiled or just-in-time compiled, just like Python, like top bottom. It doesn't have any optimization passes or anything like that. But V8 is intelligent enough to notice when certain functions or certain loops start to get called repeatedly very quickly next to each other, like high repetition, and it realizes there's some heuristics built into V8 where it will notice, like, hey, I've JIT compiled this like 3 times now, 5 times now, 15 times now, and it will actually cache the compilation output of those lines. So when it finds those lines of JavaScript in the future, it will just jump directly to the precompiled set. So going back to what I was talking about with Python, it's one of those trade-offs where for a short enough program or a program that you're only going to use once or twice, doing something that's like interpreted or just-in-time compilation can actually be faster than sitting there and pre-compiling the entire thing. And the proof of that is every time you load a web page, the interactivity, if the web page is built correctly, the interactivity loads basically instantly. And it would take much longer if you were waiting for a pre-compilation step.
Yeah. Okay. So I'm going to recap some of what you said. First of all, JIT compile just in time, just like just in time production. If you're familiar with like manufacturing or something like that, you order a part and they custom, make it just as a one-time part, as opposed to having like an entire production run, create hundreds of parts, hundreds of copies of that part. It's like, here's that one part that you needed. So that's where the term just in time was imported for software development is from manufacturing. So just-in-time compilation, V8, this JavaScript engine, again maintained by Google, and I think used in Chrome, and of course notably used in Node.js, which the FreeCodeCamp curriculum uses as the primary way to do full stack JavaScript. And of course the creator of Node.js also has Deno, which is basically like a kind of a SQL project that addresses some of the shortcomings of Node. But if you've heard of either of these projects, what's really powering them is V8. And the true power of V8 is, as you said, the ability to notice repetition within a code base and just cache the output of that like function or of that loop, so that it doesn't need to keep running it over and over. And that's how it can be so high performance, even with an interpreted language like JavaScript. And Node.js is famously extremely high performance, which is surprising considering that it is based on an interpreted programming language. So let's talk a little bit about Go and Rust, and we can talk about TypeScript too, which is basically just JavaScript with types. That is it's type safe JavaScript, so it just dramatically reduces the likelihood of bugs. Type-based bugs, my understanding, are extremely common. And it's one of the most common kind of things that can go wrong. So if somebody threw up their hands and said, JavaScript should just have static types, what the heck? And so they created TypeScript. But if you know JavaScript, you can very quickly learn TypeScript. They're practically the same thing. It's just, my understanding is it's just a little bit of additional functionality built on top of JavaScript. Is that Does that jive with what your understanding is?
Yeah. So there's kind of like a straight line that kind of goes from like your Python and your JavaScript languages through your Go language through to Rust, and it's kind of like a timeline in terms of how easy is it to write and versus how performant is it going to be, and also how long is it going to take to compile. So one of the kind of the through lines you'll notice is that the more performant a language is at runtime, usually the higher cost it has at compilation time. So something like a C or a Rust are going to be around the same. C++, Rust, C++, C, and Rust are all going to be about the same. Now, C++ has just about the worst compilation time for a programming language that can build a program of sufficient difficulty or sufficient complexity. And that's because C++ really likes to import a lot of header files almost recursively, like over and over and over again. So
quick update. I went ahead and applied for 5 jobs. This is stopped, right? Yeah. Applied for 5 jobs. I have a couple of days to apply for the Florida Claims Benefit, so I'm going to do that tomorrow. I am focused on a side hustle. My roommate and I have had a bunch of discussions about just trying to get our own startup business going. He has a couple of friends that are actually very successful in a specific area. So we've got a book, and I am going to read through it, and I'm going to start documenting everything in a new Confluent space. He said if some 20-somethings can be making 5 figures a month, then we can too. And it's my roommate. He's not bullshitting me. It's not like he's trying to sell me something. So he got the book, and we're going to try to go through it, get things documented as I go along. And I did get one message from somebody asking if I was interested in a job. And I told him, yeah, but I haven't heard back yet. So hopefully they get back in touch with me. And I did get one, but it's a scam. It's like requirements: live in the US, Canada, or Europe. 2, be between ages 20 and 75. Get the fuck out of here. That's the biggest net you can cast. You didn't even say what. Yeah, that's a scam. I'm not responding to that. I did ask Bob to. I'm just diving into it right now. So the first thing I did was get Bob to create an icon for the Confluent space. It's Uncle Sam handing you money, because it's an unclaimed funds business apparently. So he knows people that are successful at this, and I'm getting desperate, so I'm willing to do anything. He said he knows somebody that made $700 in the first week. So that'd be a good payday for me. That would cover. I only owe $900 left on my car, so I got to do something. So I'll let you know how it goes.
really the problem with C++.
As soon as I get done reading through this and document it, we'll move over to some gaming, or maybe I'll still be feeling froggy, and we'll clean stuff up. With the AI, we'll see how I feel. And this is only 63 pages. I'll be through this in less. Well, I'm going to document stuff as I go along, so it could be an hour or two, but we'll see. Oh, let me let the cat out. All right, I'm going to get back to it. This is interesting. It's good to understand the limitations of baby's first coding language, which is going to be Python for me. But it's really cool to hear how this stuff works on the back end, because I know fuck all about back end development. You're the expert there, Phoebus.
C++ compilation time there is not the code itself; it's more the header language, like the meta language, the macros that you can use up above that change the behavior of your code based on different compiler targets. Because you'll have library A that imports library B that imports library C that also imports library A, and you have like all these different like import cycles and everything. And the compiler needs to be able to handle that just because of so many years of legacy. And so that was part of why Go came into being. Was again the compilation time of C++ is so slow that they're like, we need something that's faster to compile at least than this. And while we're building that, why don't we try to come up with a language specification that is going to give us a language that's really easy to write and it's really fast to onboard new developers to, while maintaining that we need to make it high performance at runtime so we can't have another interpreted language. So Go kind of fits much closer to Rust than to TypeScript on that through line, and certainly much closer than Python. So starting back over at TypeScript and JavaScript, like I had said earlier, being interpreted languages, there's always going to be some sort of slowdown to that compared to a pre-compiled language. Now, like I said, there's a price you pay in compilation. That's a one-time cost that you pay for execution. So if you're going to execute this program twice, 3 times, 4 times, is stuff running in production? Is it running? Are we now talking? It's not just a shell script that runs top to bottom and then exits. Maybe it's a service that's running long term. Well, keep in mind that that cost is going to be accruing over the runtime of the program, not just a one-shot execution through func main or the main function. So a lot of the gains that you get are actually going to be towards more server-driven applications than for command line tools. There's a huge boon of command line tools that are written in Python and TypeScript, and they're all perfectly fine, right? They'll run through, and as a developer, you might be running it a couple dozen times a day. I think there's like some command line utilities for accessing AWS resources. I think the AWS CLI, I think that was originally written in JavaScript. It might be in another language now, but yeah, there's a lot of command line utility programs or CLIs will all be written in Python and JavaScript, just because the speed of execution isn't anywhere near as important as the developer's ability to make quick and easy changes to the code, or to test things using the like I said earlier with like the Jupyter Notebook kernels. You pause execution and do some more advanced debugging at runtime. Types added something really interesting to both Python and JavaScript as interpreted languages, because neither of them actually are used. And what do I mean by that? So in a language like C++ or Go, you've got, or especially Rust, you've got a type associated with every piece of data. And so every piece of data that you have has a shape to it that's part of that type. So if it's an int, like an integer type, you know exactly how many bits in memory or how many bytes in memory are going to be set aside for that type. And if you define a struct, or in Python, or in Python it would be a class. If you define a struct in Go or in Rust, you're going to be setting aside exactly the amount of space required for all the different properties within that class or within that struct. So if you've got 2 different numbers and then a string, like the size of that struct. You know how big it's going to be. You know what it requires to fit that into memory, especially when you're fitting an array of them into memory or a slice of them in Go in memory. So if you've got a bunch of them, you know exactly how to lay out your memory ahead of time. Now in JavaScript and Python, you can't really do that, right?
Yeah, because of the duck typing. Like so
yeah.
Like a binary takes up the same amount of space in memory as I don't know what the large string is. Yeah. I mean, what would be the biggest? I just want to make sure I'm understanding you correctly, because I didn't realize that it was this inefficient. If I'm getting this correct, that it was this memory inefficient, having a duck typed language. And the reason it's called duck type is if it looks like a duck and quacks like a duck, it's a duck.
Then it's probably duck.
Basically, like dynamic typing, where you just say var equals XYZ, and then it stores whatever that is, and it doesn't care what type it is, whether it's a Boolean or whether it's a string or an int. It just sets that aside, and then it can be changed. It can change from one type data type to another when you reassign it later. That's something that you can do with dynamic typing that you can't do with static typing. And that's what I said leads to a lot of type errors. But some creative programmers might be able to use that to do things efficiently, just to have this generic container that they can put whatever data they need into for the time being, and then they can overwrite it later. But
yeah,
but that
DHH,
comes at a cost in terms of memory, is what you're saying.
Yeah. To your point, DHH loves that about Ruby. He said, yeah, there's some projects that are trying to add types to Ruby, and don't you've got a good thing, don't ruin it. He loves his dynamic typing, but yeah, I mean, focusing on JavaScript for a moment. Essentially, every variable you ever create in JavaScript is going to be a pointer. It doesn't feel like a pointer, but it is, and it's a pointer to the piece of memory that's been allocated, but it's not just that. It's going to be like a struct. So you've got inside of your memory, you've got a pointer to the memory, and then you've got tags on it for when it was last used for the mark and sweep garbage collector, because it's also it's not just dynamic, it's also garbage collected. And then you've got the actual value, or potentially a pointer to the value if it's another dynamic, if the value inside is also dynamically sized, like an object or an array. So you end up almost like ballooning the memory that's required. And there's been an optimization made in the I don't know how many years ago for small integers. So small integers and booleans, they use SMEs, which is like a small integer, SME. And so some variables don't actually take up all the memory that's required by like an object. Where you really get into trouble in JavaScript is when you start getting into functional programming and you're doing like .map, .filter, .map, .filter, and you're constantly like every time you're calling a function off of an object in JavaScript, you're creating more memory.
Yeah.
And
that's something that you do all the time in JavaScript, because functional programming is the ideal way to use JavaScript.
Yeah, it's considered good practice to create tons and tons and tons of memory, especially memory that you're only ever going to use once in the middle of a function call chain, and then never again. And that's kind of wild, actually. But the V8 team is really good at optimizing for that. Basically, the entire I can almost feel like a sigh of desperation from the V8 team every time like a new programming like kind of fad comes on, like on the JavaScript community, where it's like, okay, well, now we want to chain a bunch of operators. Now we want to there's a proposal that came through for adding the types from the TypeScript type system into the language itself, right? And it's just like, man, I'm very impressed by how well they've managed. I also feel really sorry for the developers for all the different things they have to keep in their head in order to not just maintain specification compliance, but also to be performant enough that everyone can use all these crazy patterns and idioms like in a mobile browser on a cell phone.
Yeah.
Right. It's actually like V8 is probably one of the most impressive projects, like next to like the Linux kernel and Minix and a couple other big guys, right? Like it's certainly up there.
Yeah. Well, I'd like to talk more about maintaining open source, because that is one of the things you do. You're an open source maintainer, and we're going to get to that in a moment. But I do want to just kind of like cap off our discussion of these different programming languages, specifically Rust, Go, and TypeScript. And maybe you could give like an ideal kind of use case for each of these ones and when it would make sense to use each. So I just want to kind of step back and give you a second to like think of like an example project where like, oh, this is definitely like a place where Rust would shine. This is a place where Go would shine. This is a place where TypeScript would shine. Just so everybody listening can walk away with kind of just like some kind of general vibe for where they can be when they're trying to decide which language to use for a new project.
Yeah. TypeScript is a good language for large teams that are potentially not all in the same time zone, not all working, in the same office. The speed of development of JavaScript plus the added safety of types, which are, will help you with autocomplete in your code editor and help you with making sure that you're not introducing new bugs and that you're using function calls and signatures correctly. That will allow you to have high speed and velocity in your team's development, while also not making clumsy mistakes like breaking function signatures and then the caller is not getting back what they expected. So JavaScript just being a really easy language to write code in, comparatively to Go and Rust. Really, the power of TypeScript comes from JavaScript being easy, but then you tack on just a tiny little bit of extra difficulty on top to maintain safety so that you don't run into runtime bugs. That's kind of where I would say like JavaScript is really good for like large teams, or especially it's really good for teams that are writing a full stack application that's running both on the back end and the front end. So something like a web server with like a browser client. So for example, in React, the Next.js code base is written in TypeScript. And the reason why that's beneficial is you're writing a React app using Next.js, and you need to figure out how does this router actually work. I'm importing Next/router or Next/navigation. What is that code actually doing under the hood? You can go to definition and you can jump through and that's using the types and the imports in the type system. You can jump into the actual definition of that function and you can read it, and it's all in one language. So that's really helpful in terms of JavaScript and TypeScript. And I'm going to skip over Go for a second and go all the way to Rust.
And before we do, I have a very quick question. Would
Sure.
you consider creating a new project just in vanilla JavaScript, or would every JavaScript-related project you create going forward involve TypeScript?
If it was small enough, I might use JavaScript. So I have a Chrome extension or one or two Chrome extensions that I've published in the past. And there are less than 80 lines of code. And in fact, in the most recent version, I think using the .map and .filter that I was harping against 10 minutes ago, I got them down to about 13 lines of code or 8 lines of code.
Wow.
I'm not going to use TypeScript for something that small. There's no like the build step would take it would take longer for me to configure the build step than it would for me to just delete and rewrite the code. So in that case, I would use vanilla JavaScript. But for any sufficiently large project, especially any project that's running on the front end, I'm almost always going to be using TypeScript. Now, am I using TypeScript, directly, or am I using what's the other one where you can define your types in the comments? I'm forgetting the name right now.
I can't remember the name either.
Yeah, I can't remember the name.
There's a quick. I'm sorry. Go ahead.
Go ahead.
I was going to say I do need to do a quick disclosure that FreeCodeCamp used to use just vanilla JavaScript, and we've since migrated fully to TypeScript. And the FreeCodeCamp core curriculum does have a section on TypeScript, and we recommend like learning it after you learn JavaScript, and then just never going back.
Yeah, the word I was forgetting was JSDoc. So there's a version. Yeah, there's a version of TypeScript, and that's going to make some people mad that I described it that way. But there's a version of TypeScript. It's supported by TypeScript that you can define your types in the comments above and around a function instead of inline, which prevents you from having to do you don't have to strip the types out before you run it, which is, because JavaScript, all the JavaScript runtime engines don't actually support TypeScript. They only support JavaScript. So all the types have to be stripped away. Basically just like delete the strings from the colons and everything. Like it, you can basically semantically, you're using like a grammar. You can remove all the different types and then just run the code as is. So skipping over Go and going from TypeScript to Rust, I recommend Rust for a couple of different reasons. So when you have something that is of high criticality in nature, so we're talking like a space shuttle launch, we're talking automotive, like, because
Safety, like
cars don't seem that serious until you realize
safety,
physical human safety problems,
hundreds of millions of dollars in the case of sending up a satellite or something like that.
Yeah, exactly. And embedded as well. So Rust and Go, you're not really, with a small exception for TinyGo, I'll give TinyGo a shout out later. With a small exception for TinyGo, you can't really run JavaScript or Go on embedded hardware, and Rust has support for that. The Rust ecosystem is very interesting because if I were to draw a parallel to like kernels, like operating system kernels, that might be a little too in the weeds, but macOS famously has a microkernel architecture where a lot of the different things that were considered core system utilities, like when Windows was first released and other systems, Unix and Linux, they actually get moved out into system binaries that aren't running in kernel space, they're running in user space. And that's kind of how I view Rust a little bit. The core runtime for Rust is extremely small. There's almost nothing that I'm going to get in trouble so many times. There's almost nothing you can do with just the standard library in Rust. Even for just like async operations, you need to pull in a library. So you can pull in, and I think the most famous one is called Tokio. And it's like if you want async functionality in Rust and you actually want it to work, you've got to pull in a third-party package, right? So Rust has these things called crates, which is their version of a package, and there are a lot of crates. And I believe in the course that I put together, we built like a command line application that checks weather API and pulls, like, uses your location and pulls down the current temperature and humidity and a couple other, weather related statistics. I think I had to pull in like 7 different crates because there's no JSON parsing built in. Like just things that you take for granted. Like JavaScript's got a way to parse JSON. It's JavaScript object notation. Go's got encoding/JSON, which is built into the standard library. With Rust, you need to pull in a package. And so that's a double-edged sword because you're not going to have this large overhead from like a standard library that gets built into every Rust binary. But you do have to pull down and depend on a lot of third-party libraries. And that feels really weird coming from as a Go developer, coming from the Go standpoint. Having to rely on a third-party library feels a little bit weird because in Go, a lot of these core things are built into the standard library and they feel almost like blessed by the Go developers, right? So there are third-party JSON encoders and decoders in Go. They aren't part of the standard library. There is a standard library decoder, and that's considered like the canonical way to encode and decode JSON. Now, I think Uber has an open source project for encoding and decoding JSON very quickly. So I believe they're still I believe they're still standards compliant, but like the code that they wrote is doing some weird hacks, and it's not considered idiomatic. So people will typically end up using the standard library version, even knowing that it's a little bit slower. At least right now. That's another thing about Go is that the Go team basically has this, I don't want to call it a guarantee, but almost like this and it has been spoken, so I can't call it a guarantee and I can't call it an unspoken promise. It's not really a promise, but every new Go release that comes out is usually slightly faster than the one right before it. And if there's some sort of trade-off, they'll usually trade like using a little bit of extra memory for higher speed, because generally people care about their speed. Like when you look at like a data center or a cloud, like Go is very data center and server driven. Data centers are caring more about their compute costs than their memory costs in a lot of cases. Memory has gotten very cheap. Compute has gotten more and more expensive, especially as we're competing with, the NVIDIAs and the OpenAIs of the world. I know that those are primarily GPU companies, but they're using up the same fabrication and the same the same fabrication capabilities.
Yeah. So just to be clear, like
they're still competing.
There are so many, silicon kind of foundries where they actually print the chips essentially.
Yep.
And if most of those are being used to print like ASICs and GPUs and stuff like that, it does ultimately reduce the total amount of compute being introduced into all these data centers around the world that is not dedicated toward, massively parallel operations like powering an LLM and doing inference and stuff like that, or training or inference. So what you're saying is the Go team will usually just say, oh, memory is not the bottleneck here. It's actual like performance in terms of like how quickly, an actual program gets executed. Am I accurately?
Yeah, and I hope, I mean that's what I said. I hope I'm not mischaracterizing the goals of the Go team here. I think, I want to say they've been really good about memory as well. It's just that when there's a very clear optimization win for compute will usually win over memory. Is what I've noticed, at least. And I could be incorrect on that, but that's what I've noticed over time.
Okay. And
so then
that's like an organizational philosophy. Like they always want Go to be getting faster. Naturally, as they add more features, it is going to kind of slow stuff down. So they have to figure out ways to like further optimize what they have to compensate for the additional bulk that they're adding. Kind of like if you're trying to run like a really long race and you have to keep adding like additional limbs or something like muscle mass, you need to be sure that you're able to like still move that muscle mass even though you're bigger at least the same rate as you were doing before, ideally faster. So maybe you have to compensate, or maybe a rocket would be a better analogy. Like you're adding additional stuff to like you add more fuel to the rocket, but that also increases the weight, which means you have to add even more fuel, which adds even more weight. So you have to make sure that like the fuel you're adding is actually the rocket's still able to escape.
Yeah, exactly. I mean, Go binaries are very large compared to binaries in other languages because that standard library is so big. Because every time you build a Go binary, you're even if you're writing a very simple command line application, single threaded, top to bottom, 20 lines of code, you're still bundling the garbage collector, you're still bundling the runtime, you're still bundling like there's like this fixed cost overhead that you have building with Go. So to wrap up why I think someone might pick Rust over Go or over JavaScript, I would say, again, the biggest reason I would recommend it would be for something that's human safety critical or just safety critical, I suppose. The other good use for or embedded, the other good use for Rust is when you're doing a rewrite. So I personally will probably, well, at least I'll try, will never pick Rust as the language that I write a program in for the first time. Because a lot of the time when you're writing code in any language, you are learning new things about the problem space as you're writing the code. And it becomes kind of like an evolution, I guess, of your code base over time as you are meeting your initial requirements and then realizing some of your initial requirements were wrong and throwing them away and coming up with new requirements. Or maybe you realize that two of your requirements are in conflict and you have to decide which one wins out. So there's code is rarely, if ever, written exactly as initially designed. There's almost always going to be some sort of change. And it doesn't matter how good your specification is. Unless your specification is the code, because we have a word for a specification that is exactly, word for word exactly what you want. It's called code. Yeah.
Yes. And people misunderstand this all the time. I'm just going to take a moment to get on my soapbox. Okay. People think like, oh, I can just tell GPT what I need and it's going to write the code. Like if you tell GPT with the sufficient specificity, you are essentially writing that code yourself. And people who don't understand, like a lot of non-technical people don't understand that, like, if you want to sufficiently articulate what code is essentially just the tersest way of articulating what should happen. It's communicating to the computer. So sorry, I didn't mean to take you off, but I want to clarify
exactly where I was headed. Yeah. Exactly where I was headed on that. And so we have a history with all these different languages of putting all of the behavior into, well, or at least most of the behavior into the code itself, like the top-down control flow in the code. So we have, let me rephrase that. We have a history of having a problem that we need to solve and then encoding that top down, left to right, top to bottom into a code base in terms of like statements that execute. And then there's exceptions to that with things like Lisp and other languages that aren't top down statements. They're whatever, but you get the point. You can still kind of read it left to right or right to left. There's exceptions to everything, but with Rust, it's kind of coming along and saying, okay, we're going to actually encode a significant chunk of the behavior of this code base into the type system. And when you have your behavior predefined, that's a really powerful thing. Because you know you can't do X or Y with this struct, and you should never be able to. Well, the compiler will now prevent you from being able to do that. If for example, you've got a piece of memory, let's say, for example, you're writing a password manager, and you want to make sure that this piece of memory is never accessed more than once, that's something that you can encode into the type system, and it will never be accessed more than once. The compiler won't let you build a program that tries to access it more than once. And then your requirements change and you realize, oh, well, actually, we need to require it once to display it and then another time to copy it to the user's clipboard. And now you have a decision. Are you going to rewrite your type and it's going to affect all of the other, and in Rust, they'll call them traits, right? Not types. So sorry if I'm offending Rust developers out there, but you have a decision. Am I going to rewrite my trait or rewrite my type? Or am I going to make an exception and create a brand new type just for this one use case and apply it just to this data type? So you end up with a lot of churn in a Rust code base when it is your first write through of the code base. And oftentimes it means like re-architecting or rewriting all of your code as opposed to a small piece of it. If you write the code base through and it's functional in another language first, you already have like a clear roadmap and a clear path on what it is you have to do. A subsequent rewrite in Rust can almost always give you benefits in terms of speed and clarity and even cut down on verbosity a little bit.
Okay.
So I would recommend Rust for rewrites as well.
Okay, so I just want to step back real quick
Yeah.
and share. Like, so first of all, I'm learning a tremendous amount. This has been awesome. So pretty much everything between Go and Rust, and even TypeScript and Python, it comes down to like developer experience trade-off versus actual performance
Yep.
trade-off when you're actually running the application a whole lot of times. So if it's going to run a whole lot, then naturally the actual development process, the time that goes into writing it, is just a fraction of the consideration, probably. But if you're the only user and you're just writing a script that is just going to be run periodically and probably not use even a fraction of your system's memory when you're running it in the background, just for your command line interface script, like I have tons of those that I run throughout the day to get different things done, then it doesn't really matter. And developer
Right.
experience is the most important thing because you
GPT will let you build garbage because you don't know any better. No, that makes sense. That makes sense to me. If you're he said, well, no, it makes logical sense actually, because he said if you're writing the prompt, if you're writing a sufficiently if you're writing the prompt, then and you're telling ChatGPT to do it, then you're still the one writing the code. So if you don't know shit about coding, then garbage in, garbage out. That makes perfect logical sense to me.
may need to go there and customize it and stuff like that. And then moving from something like Python to Golang, or Go as we've been calling it, but you'll also hear people say Golang. This is the same thing. Essentially,
So he might disagree with you, sure, but as Spock would say, that is logical, Captain.
you're kind of moving on that spectrum of like the developer experience is slightly more constrained, but it's also a way faster. And then if you move way off to the other side of the spectrum, that's where you have Rust, where everything is you're importing something and everything has to be like deliberated about beforehand. And that's where you said having like a sufficiently written spec code from your first version of the application that basically serves as your map for how you're going to actually write this code. So, and you've already maybe been running it for a while in production, and you already have a good idea of like this is more or less how it's going to be for some time. So you just want to rewrite it in Rust and make it a little bit faster, essentially. Like you.
Well, I don't know. This goes back to like the this is why you and I are friends, is because our definition of minimum viable product is very different from most people's. Right? So I don't think there's a problem writing something that's large and complicated, as long as you can specifically justify the reason for doing that. Most of the time, there's a really good reason for needing to build something extra and make it part of an MVP. But most people don't want to listen to that. They're like, oh no, you're changing the scope of the project. It's like, but you forgot a critical piece. We'll get it next iteration. But you're going to break all this shit and then I have to fix it.
Use fewer resources, maybe make it like slightly safer and stuff like that. So again, you're moving down the developer experience to high performance spectrum, essentially, as you go. And I just want to make sure that my understanding of this is correct. Python would be at the far edge of that, the easiest to use, the best developer experience. And then, you'd have your TypeScript, and then you'd have your Golang, and then at the far edge, you'd have Rust. And of course, you go even further down than Rust. But that's like as far as we're going to talk about in this podcast.
Yeah, exactly. Yeah. And of course, developer experience there's also always going to be a subjective element to that. For me, the developer experience of Go is going to be easier than Python because that's the main language that I write in, right? And it's going to be different for somebody else. Someone else's just does nothing but write Zig all day long. They're going to have an easier time writing Zig than they're going to have writing a sufficiently complicated Python program. So yeah, I mean, I would say that's perfectly characterized as what I was saying.
Awesome. All right. So just to recap what you're saying then for ideal projects, like let's say you have just a script with an audience of one, like you're just writing something only you are going to use. You're making some random open source library that you're going to yeet onto GitHub, and maybe somebody will, use it themselves, but who cares? You're just moving on with your life. You're not planning to actively maintain this. Python might be a great thing, or if you're already familiar, just whatever tool you're most familiar with, you might write such a script in Go. And then Rust is really just for doing rewrites is the primary thing that you said. Like I know that the Linux kernel project, one of the most important and most sophisticated open source projects on earth, they recently started allowing, Rust for, I don't know the extent to which it was allowed in, but maybe, do you know very much about that? Can you talk about that?
I know an awful amount about that, unfortunately.
Okay.
Yeah, it's
give us the skinny.
It's full of drama. That's the short version. It's full of a lot of drama. It has been allowed into one subtree of the kernel for device drivers. And it's a situation where there's first of all, there's a very successful project called Asahi Linux. That the goal of it was to get the Linux kernel ported to the M series MacBooks. And so there's a long saga of all the drivers and everything that were written for that project were all written in Rust. I think it was just after the announcement that Rust was under consideration for a language that would be allowed into the kernel. There has been a lot of drama over actually getting the patches that have already been written and are working accepted into the kernel. And not to both sides this too much, but there has been a lot of drama and unnecessary grief over the whole situation. There's maintainers that say, I don't want to maintain a code base that has two languages. I read and write both of these languages, and just the fact that I'm moving from the responsibilities of maintaining and authoring a one language code base to a two language code base sufficiently increases the difficulty of my role enough to the point at which it's not worth doing for me. So I quit. Like I'm out.
Wow, that's
it. And then yeah.
I mean, lots of code bases have multiple languages. I would say it's probably pretty
sure.
rare. Yeah.
Sure, but a compiled code base that has as many eyes on it as the Linux kernel, with as many paying corporations that
Sounds like somebody wants to be lazy.
are using it for everything and sponsoring and require high reliability. And we've had very recently a couple of things slip through all the way to release candidates that really shouldn't have. And
Are you talking about like bad code, or are you talking about like attackers?
Bad code in the Linux kernel. So I mean, there's also very famously there was the XZ utilities stuff, but that's not really part of the Linux kernel, so that's not really what I'm talking about.
Okay.
But there's been stuff where Torvalds will receive a patch, or Greg KH will receive a patch. Those are the, Greg KH is like the number 2 on the Linux kernel right now in terms of approving and releasing patches. And they'll receive a patch and they'll say, this should never have even gotten close to making it to me. Like, it should never have gotten this far. How?
Well, I mean, there's a difference between making something unnecessarily overcomplicated and using the right tools for the job. You need more than a hammer to build a house, right? You can't build a house with just a hammer. You need a saw, you need a screwdriver, et cetera, et cetera. And you're technical enough that you can identify and justify that. Plus, you can think of most of it up front. That's the other thing. We share is we can build stuff in our head using different components. That's why I'm so good at video editing. You apply like the same thought process and stuff to coding and the back end development, all that stuff.
How come it slipped past so many layers of review? Now, to be totally fair, companies that develop I believe like MediaTek and Broadcom and Intel and AMD and like a lot of chip makers will submit large patches to the Linux kernel even before their CPUs are released, just to make sure that they run day one in data centers and for consumers and everyone. And a lot of the time that's very obscure in an obtusely written code that Torvalds has admitted, like, yeah, I merged it and I have no idea what it does. I hope it works, but it's your tree branch, guys. Like, it's your driver and it's your hardware, so it better work. So it's not like having obscure code merged into the kernel isn't a thing that happens. It's just not like, I think a lot of people are complaining about it because they don't understand the Rust code that's being written, or they disagree with the architecture of it, and they don't want their neck to be on the line for merging a bad pull request in.
Yeah, and I can imagine
there's a lot of drama over that.
I mean, device drivers, like, just for clarity, like things that you plug into your computer, essentially, whether that's a new like graphics card or whether that's a mouse, like everything has to interact somehow with the, like, at least indirectly with the kernel to actually work on a computer, right? So I can't imagine, like, you and I are open source maintainers. I just can't imagine the complexity that Linus Torvald and Greg Cage and like those people are dealing with, and it's got to be terrifying getting like a PR for, I don't know, thousands of lines of like C++ or something. Like, yeah, I guess.
Yeah, well, no C++ in the Linux kernel. That one's not allowed yet.
Oh, it isn't. Okay, what is?
No, it's just C.
It's just C.
Just
they don't even
C.
use C++.
No. Linus is ideologically opposed to C++ and for many reasons.
Okay.
What
are
mostly
some of the
just
reasons? Because, like, is it memory safety or?
I think it's more the style of the language, because you have every possible feature in C++. Like, C++ has every feature from every other language ever made. And that's a joke. There's no borrow checker from Rust in there or anything like that, except there's a new proposal out for something called Safe C++. So even if I try to make a joke about, C++ doesn't have X, it's like, well, actually, hang on. There is a way that it does implement that. With C, you basically end up arguing over variable names and indentation and maybe where you put your curly braces. There's not a whole lot of options for writing, C can only be written in a few different ways. In C++, you've got objects, you've got templates, you've got all sorts of different like patterns for writing code.
Yeah.
I probably don't even know a third of them.
Yeah, I know people that are C++ devs who feel like they still have a fleeting grasp on the language.
Yeah. So yeah, he's very, very opposed to that in the kernel. So it's just Rust and C, and then I think there's inline assembly in a few places as well, especially for the cryptography libraries.
So that's the main source of the drama, is just people don't want to have to like learn a second language or maintain it. Like, and so essentially my understanding is they were like, okay, we're accepting, Rust contributions to the kernel. And
Yeah.
then they realized, oh damn, like a lot of people so there are a lot of work that's already been done that's waiting to get merged, and people are feeling like they got bait and switched.
Yeah, a lot of it is, I wouldn't say it's just not wanting to learn the language. A lot of people are afraid of how it's going to cause the Linux kernel to change, because people will depend. So there's a parallel tree for the Linux kernel as well that's like got all the Rust stuff implemented in C. Because some people may not want to compile the Rust version of the kernel. I don't have cargo, or I don't have anything. I don't have the tool chain on my system. I'm not going to build that one. I want to stick to the tool chain that's always worked. I've got pipelines that run, like build pipelines and CI.
You have to
and
maintain a parallel version.
There is a parallel version of the kernel that does not have any Rust. Now, I'm not saying that they're one-to-one feature like one-to-one on all the features. They're supposed to be, from what I understand. And so that has also drawn some ire, because the people that are writing the Rust code will use a function or some functionality that can't be done in C, or the people that are writing C will use something that would have to go into an unsafe block in Rust, which basically strips away all the memory protections from the borrow checker in Rust, which is something you have to do sometimes, and probably more often than you'd want in Rust, but ideally you don't do that. And so there's just arguments on how things should be architected, because if you're going to write the same code base twice, maybe you should also architect it similarly, so you don't have to context switch. You already have to context switch between languages. Now you got to context switch between architectures used within one language versus another. But if you don't do that, then you can't use the features of one language versus the other. So I think that's more of what the argument is about. The C maintainers and the Rust maintainers not agreeing on the way something should be done, rather than just it being two languages. But there was absolutely, on the mailing list, there was a fight that happened where a C maintainer left the project over not being able to, I don't want to say not being able to handle, because that's a little bit rude, not being able to, basically not being able to deal with having more than one language. So
and many of these contributors are just completely unpaid. Like, a lot of people probably get paid by a company. Like, I am, an open
Drama.
source contributor. Like, a lot of open source is actually funded by big technology companies who have devs who help maintain these open source projects. There are also a lot of volunteers out there. But this person, were they just like a pure volunteer when they left?
I'm not sure, actually, and they didn't leave Linux kernel development entirely. They just got removed from that that group. So they moved. I don't even know if they moved to another group. I think they were maintaining multiple different groups within the Linux kernel, and then they left the device drivers tree.
Okay. Yeah. Interesting. Well, we could talk about this for a while. I've learned a tremendous amount so far. I want to get into more stuff. As I promised, in the intro that I haven't yet recorded, but I'm going to promise this in the intro that I'm recording, that we'll talk a whole bunch of technical stuff, and then we'll get into more general actionable tips for people who essentially want to get in the position that you were in. So let's start with the autobiographical background of you, Ty Groot. And yes, your last name is pronounced the same as the Guardians of the Galaxy tree-based life form.
Yep. Spelled the same way too. Yeah.
Yeah.
Well, I mean, how far back do you want to go? So I've been writing. Yeah.
13, I think, is when you started coding.
Well. So I guess my story would start when I was 8 years old. So I was originally I was 8 years old, but when I was 8, I was really into creative writing, and I really wanted to write a story. I wanted to write a book, but it just didn't seem right to me that I had to write it down on paper, and paper could be lost, and I couldn't make a copy of it without handwriting it over and over again. Surely there must be a better way. And my parents had an extra computer in a spare room that we had, and I basically just asked them, like, can I type my story into the computer, and then I can print it out on 2 pieces of paper instead of 1, so that I don't lose it. I'm not really thinking of files or anything, or like this is before flash drives were as ubiquitous as they are now. So it was just like, I can connect this to a printer, and I can print 2 copies of it, but I only have to write it once. So I was writing a story, and then, as children sometimes do, I decided, oh, you know what? I don't actually want this story to be about pirates. Now I want it to be about monsters or whatever. I was changing the story. And because it changed the story, I wanted to change the title, because the title didn't fit anymore. So I had seen my dad do this many times. I go to I hit the minimize button, I go to the desktop, and I rename the file, and I hit enter, and then my file doesn't open anymore. And I don't know why. And Microsoft Word, 2003, Microsoft Word 90, I don't remember what version of Word it was, just crashes. It doesn't open anymore. I can't open the file. I would always open my story by double clicking on the icon, and it didn't work anymore. So what I actually did was I didn't add .doc to the end. This is before docx.
Oh, okay.
Didn't add doc to the end. And back then, Windows wasn't as hand-holdy as it is now, and it actually lets you rename the file extension without prompting you. So the association between that file and Word was broken. And if I tried to open it, it would open with Notepad, and you just see like a bunch of XML and not binary like ones and zeros, but like base64 encoded, like jumbled high entropy characters just like all over the screen. And I'm 8. I don't know what I'm looking at. But that's kind of what hinted to me like, oh, there might be more to a computer than just typing letters in and seeing, stuff on the screen. Fast forward years later, I had a friend in middle school through high school. His name's Jonathan, or John, as I called him. His dad worked for a company that did a bunch of very highly technical company. I'll leave it at that. And he was very into Python. So he kind of got me into Python. I remember a formative moment for me was he showed me like, oh yeah, by the way, we can write a virus in one line in Python. And like, I don't know what a virus is, but that sounds interesting. What is that? And he basically wrote like a fork bomb in Python and showed me how to write it.
A fork bomb is essentially like a procedure that just keeps copying itself over and over.
Yeah, it's a program that'll call itself twice.
Okay.
Yeah. It'll call itself twice, usually in a separate thread, so that you have 1, then you've got 2, then you've got 4, then you've got 8, and eventually it'll consume enough system resources to you'll run out of memory. And there's ways to protect against that on modern systems now, but back then it was enough to crash a computer. And so that was fun. And then in high school, I had a teacher, Jason Parker. I went to Valencia High School for the first 2 years of high school, and that was he was teaching us there a Java class, AP Computer Science, and that was a really great class. He was a really great teacher. He had answers to everything, and he was always right. He'd answered every question we'd asked 100 times before. And there was always like something that you could do to finish the assignment, and then something you could do past that for like extra credit. But it wasn't just like extra credit. It was like he would be really invested in how you solve the problem as opposed to just solving the extra credit problem. And he really got us all thinking about how computers really work on the inside. And now keep in mind, this is in Java even, where you're a Java virtual machine away from bare metal. So really thinking about how objects are stored in memory and all that sort of stuff. And that was really helpful. I went through, I ended up actually getting a job right around then as well. I had a contracting job that I had been doing since I was around 13 to 12, 13, somewhere around there.
Wow, so you were making money
company
as a dev, essentially.
$8 an hour, but yes, I was making money.
Yeah, well, $8 an hour is not bad for a 13-year-old. Like, I grew up in Oklahoma City. I didn't grow up in California, so I don't think I had a job that paid more than $8 an hour until I was like 22 or something like that. Like all my jobs were like less than $8 an hour, but cost of living was obviously a lot lower. But please carry on.
Yeah, so there's a family friend who needed help with something. They were running a small contracting company, and they were just really busy, right? It was two dads that both have large families. We're talking 9, 12 kids each, and
Cheaper
they just didn't. Sorry, yeah,
cheaper by the dozen. The Steve Martin movie.
yeah. They just didn't have time to do some of the more boring things, but for me it was exciting. So one of those was like they wanted to figure out how can we triple boot Windows, Mac, and Linux on a Mac Mini, right? So I remember I pulled a TV into my garage and had the Mac and the keyboard and all my different flash drives with my different boot ISOs, and I was like trying to figure out, okay, so if I boot and I install Windows first and then Linux, on into the dual boot partitions for this Mac, that works. But if I do Linux first and then Windows stomps on top of Linux, so then I have to redo Linux again. And I think by the time I ended up handing it to them, it was like quadruple booted between like it had like Ubuntu, and then it had it had Debian, and then it had Linux Mint, and then it also had I think Windows 7 at the time, and then Mac OS, whatever version it would have been at the time. And then they also had these small like Python scripts that they would throw over to me and say, hey, can you fix this, or can you make this work, or whatever. And so I did some of that work with them. A lot of soldering and a lot of circuit board assembly as well. And I ended up actually getting my first full-time job from them as well. So when I was a little bit older, their contracting company ended up getting effectively acquired by a small elevator and equipment company that was trying to do some like Skunkworks back of the building IoT program before the word IoT was even coined.
Yeah,
they were trying to do.
Skunkworks is a reference to which contractor was it? It was was it Northrop Grumman? It was one of the big contractors, but they like built like this tent out in their parking lot, and they had people work on. I think that's where they developed the supersonic jets. Yeah, but basically, when you say Skunkworks, for anybody who doesn't know what that means, it's essentially when you have your normal company, it's still business as usual, but you got this separate thing out back where you're kind of like doing your moonshot type. Google had like the X project, or I can't remember what it's called, but basically
X Labs, yeah.
X Labs, yeah. So is this where you're doing completely experimental stuff that might come to something or it might not?
Yeah. Yeah,
so
the
elevator company.
Yeah, so by day they're doing elevator maintenance, and then there's this back room that we had. They hired a whole bunch of college students and then me, and then the two people that ran the contracting company I was with earlier. They hired all of us to build Internet of Things or IoT like small embedded circuit boards with onboard Wi-Fi that could connect to, like the Wi-Fi at a CVS or at a Walmart, or we also did personal and private elevators for like retired basketball stars with bad knees and stuff. So like maybe their home Wi-Fi, and it would track how many times the elevator goes up and down. It would track the vibrations. We'd plug directly into the PLC, or I don't know what it actually stands for anymore. We always just called it a PLC, like the main board for the elevator.
Yeah.
The controller, and we would track every little interaction, every metric that we possibly could, collected over time. And this is before machine learning was in the popular landscape that it is today with OpenAI and everything. We were trying to build a model to determine when can we predict with high certainty that your elevator or your escalator or whatever, your load dock, your lift, is going to break before it does, so that we can send a technician out for preventative maintenance, and then you have zero downtime, or you have 15 minutes of downtime as opposed to waiting for us to get there. And so that was a massive undertaking. It was a 4 or 5 year project. They ended up, I don't know if I'm allowed to tell how that story ends, so I'll probably leave that there. But that was my main employment for 3 or 4, maybe 5 years. And then fast forward through.
And while you're fast forwarding, just a couple quick notes. I think you said PLC, programmable logic controller.
Probably. That makes sense.
Yeah, and that's basically like used in industrial automation, so like elevators. Essentially, like it's like a ruggedized, I don't know, but it's designed to be like used extensively for a long period of time and like be, reliable. Essentially, more so than maybe like something that goes into a PC that has like a nice fan and all that stuff. And then the other thing I was going to say is it was not Northrop Grumman, it was Lockheed Martin. The other defense contractor. That's where they had the
other one.
Yeah, the Skunkworks. So I just like to not have misinformation on the podcast, and if I say something I'm not sure about it, I'm going to look it up and correct myself. Please carry on. So how old are you at this point?
Oh, not sure. I guess I would have been in high school. Oh, no, that job carried me through the first couple of years of college, so it would have been about 20, I guess.
Yeah. And keep in mind, the first few years of college, so you did college concurrently with high school. The last 2 years of high school, you were able to also attend community college?
Yeah, so I guess I effectively did 5.5 years of college because my second half of my junior year and my whole senior year, I also went to a community college. I went to Fullerton Community College. And so I actually graduated early. I believe the beginning of my junior year, I tested out and did there's like an exam you can take in California to get a diploma equivalent.
The
And-
GED? Is it that?
wasn't I don't think it was the GED.
Okay.
I think you get a GED, but the test that you take is different.
Okay.
I think I do have a GED from that.
Okay. I have a GED too. I
yeah.
just left school and then took the test. It was a lot easier than finishing high school.
Yeah.
But
yeah.
I'm not encouraging people to do that. You can't get scholarships and stuff like that if you have a GED, you generally. But I digress.
Well, I didn't have that issue. I actually got the presidential scholarship at Santa Clara University, so my tuition was covered.
Wow.
With the GED. So
That's great.
I would advise people to do a little bit more looking into that and make sure, because I'm sure it does disqualify you from a lot of them. That wasn't a problem for me specifically. But I also didn't just drop out of high school and then go like take 2 gap years or something.
Yeah, that's what I did.
Oh, okay. Well,
If you want to call living in your car and working at Taco Bell a gap year, sure. It's not like I was
Okay,
traveling
all
around
right.
Europe. But yeah.
yeah. No, my point being, I went to community college for the remaining. So I still did like a 4-year education during high school. I just spent the second half of junior and all of senior year at a community college, which apparently was the wrong way to do it for other reasons as well. Because in California, with some community colleges, they'll have a program, and my brother and sister did this. So I know from personal experience. You are allowed to attend a community college for free if you are still in high school. The courses are, or maybe it's like $20 or something. It's really cheap or free. I can't remember, and I can't even remember if the $20 was like for meal points or something. And by getting my GED and graduating, I had to pay full price, which, you know, for California community college, it's all highly subsidized. It's actually relatively affordable still. I think it's still, you know, it's a few $100s.
Yeah.
It's not
Which is nothing in the grand
Yeah.
scheme of things if you're unfamiliar with the cost of U.S. higher education.
Yes.
California has something called the Master Plan, I believe is what it's called. And it's essentially like they created all these community colleges, and there's like basically the best community colleges on earth. And they're also incredibly affordable. If you're looking for affordable education, my humble advice would be go get California residence and send your kids
Yeah.
to California Community College, and then see if they can, you know, transition from community college to a good, you know, research institution like you attended, or a California State University, you know, schools, those are great too. But like California's got just like chef's kiss, like best higher ed you can get basically. And a lot of it's public.
Yeah, the community college that I went to was great. Yeah, again, especially considering the price, it was great. And they also had all sorts of community events. So one other thing that I went to is before I even started my computer science class, even in high school, there was an event that they were offering. It was led by Llewellyn Falco, if you know that name. He was one of the he was an engineer at Google for a while. He was one of the Google Glass ambassadors back when those first came out, their augmented reality glasses. And he did like an intro class to computer science. I was actually in between chemistry and computer science at that point. I wasn't sure which path I was going to take, and that helped kind of solidify and push me towards computer science. And then high school kind of crystallized it completely. And that was all offered through the community college. And I think that was like $5 to join. It was like a registration fee or something like that, or $5. So yeah, and then in college, I ended up, you know, after the work with that elevator company kind of shut down for me, I ended up getting a job with a company called CellPoint Systems, which is actually my current employer right now. And that might be confusing because we spoke ahead of the call and I mentioned a few different things.
Yeah.
I have a lot of irons in the fire. So my primary employment is with a company called CellPoint Systems, and we had a large contract with the FANG company that has a lot of love for the Go programming language. So in order to help kind of secure that contract, we promised them we would write everything in Go. That ended up being how I got introduced to Go. So I guess I'm more of a relatively recent convert, only about 6 or 7 years, maybe 8 years of Go.
Yeah.
But yeah, so we started using Go. We started using Go before there was a Go package manager, like the Go module system didn't exist yet. So it was really rough when we first started. But it came out almost immediately right after I started writing Go. So that was very nice. That's been probably the best thing that they've added to Go, is the package management is really, really good. Especially because you don't have to have a registry, you don't have to have anything, you don't have to like use pip or have like the npm registry or JSR or any of the other, that's the JavaScript registry that's tied in with Dino. You just have a Git repo with a public URL. Congratulations. If you tag your Git commit with a tagged numerical release like v1.1.1 or 1.1.2, and you have a public Golang package that can be used and imported by anybody. That I think is one of the strongest points of Go's ecosystem right now. So it's gotten a lot better since I started working there. But that was kind of my introduction, is when I started work at Cellpoint Systems. Over time, that contract grew and expanded and grew and expanded. We grew the team. It was initially just a couple of us. It blew out to maybe 8 or 10 of us at the largest point, including all the hardware and the software engineers. And then I ended up leading that team over time. The head of that team started becoming busy with other things, and I ended up taking over the team. And I ran that project for several years. The contract finally came to an end. We had renewed it like 3 times, and then it's finally like, okay, there's no need for renewal anymore. That project kind of came to an end.
Hey, Swanty. Yeah, I stayed up way too late again last night. I think I went to bed at like 2:30 last night. I got to get to bed before 1 tonight. Let me make a reminder. Where's 1 a.m.? Right there. I'm making a reminder right now. Get to bed. Get to bed. Take Benadryl. There we go. Okay. All right. Yeah, I got to get to bed by 1, and then I got to get bed by midnight tomorrow. Let me mark that here. Here. 12. Let's do get to bed. Take Benadryl. There we go. Yeah, my sleep schedule got completely messed up from like it was 2 weeks ago now? It was a week and a half ago now. Yeah, it was a week and a half ago. I had the most epic game of Helldivers 2. I had like adrenaline in my system. It was at like 1 a.m. I tried to go to bed. I didn't fall asleep until 5 a.m. And then I just haven't been able to get back on a normal schedule. Well, actually, I am starting to stream earlier because I stayed up for like 28 hours Monday and Tuesday. Yeah, stay awake for 24 hours. So I did kind of reset my schedule a little bit. It's getting better. It's getting better. So I'm trying to slowly adjust again. I don't want to spend another 24 to 30 hours awake. That's I'm no spring chicken no more. So give me a little bit of time, and I'll walk the clock back some. And then I'm doing pretty good. Thanks for asking. We're checking out. We're listening to these guys talk about the strengths and weaknesses of different types of code. And then I'm in the process of working on a side hustle right now. I'm reading a book and taking some notes, and then I got a buddy who we're going in a business together. And we'll see if we can't start making some money on a side hustle. So I'm just reading through it and taking notes, and then watching this in the background. So I should be done. I'm going to give it like another hour, and then we're going to switch over to gaming, and just be hanging out. So I don't think the exciting stuff will really happen in about an hour. I would love nothing more to do nothing but gaming, but I got to sit in front of the computer and focus on other things besides that for the immediate future until I can get some revenue coming in, because I got laid off like 3 months ago now, and I'm running out of cash. So I gotta work. How you doing?
And then the president of the company, it's a very, very small company, first of all. We're at most 20 people and usually around 6 or 7, I think. The president of the company, his name is Rich, because it's such a small company, he's my boss. He's the owner of the company, but he's my boss, but he's also like kind of like my friend. And so he and I got to talking. We started having some ideas about some of the pain points that we had during this contract with the FANG company. And a large part of that was due to SaltStack.
Yeah.
SaltStack
And
is a
you've written
great
an
program.
article basically like breaking up with SaltStack.
Yes.
And you
Yeah,
use
exactly.
that no longer best friends with meme.
Yeah. So I won't go into full details there. If you want to read about
I'll
the
link to
beginnings of Garlic, he'll put a link to my blog. But I was introduced first to SaltStack at that equipment and elevator company, and kind of brought it with me all the way through to the through the role that I had at CellPoint. And there was just one thing after another. There was like a major critical vulnerability that, in my opinion, was not addressed properly. And then we were getting crashes at runtime due to high memory usage and a bunch of other things. I was talking to Rich and we're like, well, it would be really nice if we could solve some of these problems, because I'm sure we're not the only ones having them. SaltStack is used everywhere. I think all four of the old FANG companies, four of them, were using SaltStack, and then a bunch of other Fortune 100 companies are all using it. Fortune 500 are all using SaltStack. So like, well, we can probably address this problem, and then to drag it back to the beginning of our conversation, bring it from an interpreted language like Python, which that's what SaltStack was written in, to a compiled language like Go. And it'll take a little longer to write it initially. It'll take a little longer to compile it at build time. Fine. But the end result is we get a single binary that can be just dropped onto a system without having to use apt or RPM to install a whole library of packages and dependencies at runtime. So when you're dealing with something as important as rolling out servers and making sure that all of your developer operations and everything is all like solid, and when I hit deploy, it actually deploys and it goes out and we have a server spun up. The fact that you have to install 30 some odd dependencies alongside SaltStack to get SaltStack up and running, and then do configuration of it, as opposed to just dropping a binary, dropping a systemd service file and saying systemctl start and just having it run. There's a clear advantage to using a static, like a precompiled static binary.
Yeah,
like
so it's just getting things live faster and like not having to worry about those dependencies. Dependencies do break sometimes. And if you're like...
In our experience, they broke all the time in production. And a lot of these devices that we're dealing with are on cellular connections in a remote desert. And now we're just hosed. So we can't deal with that. We need something that's going to be stable. And you have a trade-off between,
I just started and I had dependencies break on me.
Turn auto update on all these remote systems so that we get, security updates from Ubuntu or from Canonical.
Because that can bring it down too.
And then lose the stability? Or do we just stay, vulnerable, and then we only do like patched updates when we know that they're tested? And the problem is when you have a lot of devices that have to operate in the field and they remain connected to the network, but that network may lose connection to the internet. For example, like in a retail store environment or something like that, you're still susceptible to incoming attacks on that store network. You got customers connecting to the Wi-Fi, but you don't have the ability to auto update or push controlled updates at a set time.
Yeah.
So your best bet is going to be auto update then to maintain security, but then you lose stability. So it's all these different trade-offs and stuff, and I really wanted to avoid that. So that's part of the main thing behind Garlic.
Okay, so Garlic, spelled GRLX. Basically, the reason for it to be is you can have a binary that you can just drop onto a system, and then when you need to do some sort of security patch update or something like that, you're not actually going in and running a bunch of procedures. You're just essentially.
Oh, hey, Silver Rules. I got about an hour left of work to do, and we're watching two coding geeks talk about coding because I'm starting to get into it, and they're talking about the different types of coding languages and some of their strengths and weaknesses and some of the common pitfalls that they deal with and all that kind of stuff. So I find this stuff super interesting. It's probably a bit too much for some folks, but gaming, I'll start gaming in about an hour. I just need to spend like 1 more hour reading through this book and making a bunch of notes, because I'm going to start up a side hustle with my roommate. And this looks totally doable. I know we can do this. I just gotta. I'm reading through the book, and there's a lot of things that I need to research before we can get started. So that's what I'm doing: reading through it, taking notes, and then I'll be spending a couple hours each day working on this project. And then I'm in the process. If you go check out the YouTube channel, the Skyrim videos there. I don't know if you've seen that yet. I promised that back in like 2012. And then the most recent video is all the progress that I've made with generative AI. So I've been teaching myself how to set up locally hosted generative AI. And it's going to really help with a bunch of video production stuff. If I can get all this stuff figured out, I really will be a one-man production studio. We're talking about like automating 80 to 90% of the VFX pipeline when it comes to video production. So if you want to kind of see the nuts and bolts of that behind the scenes stuff, go check that video out. If not, stick around. Like I said, we're picking up some game in about an hour when I'm too tired to focus on this stuff anymore. But got about 60 minutes, about 55 minutes left.
Actually flashing.
Oh, and thanks for stopping in and saying hi. Olama, it's essentially open source AI with no restrictions. Yeah. Oh, here. What's his name? John Carmack. We just got done. Let me find the thing and link it to you. So John, you know who John Carmack is, right? The guy who coded up Doom back in the day, and he's been running id and all that kind of stuff. So he's, they've been training all the AI stuff in virtual environments, right? But he's like, well, what would it take for the machine learning to actually play a video game like a human does? So he's open sourcing this project, and you basically build a little robot control mechanism that moves an Atari controller around and pushes the Atari button, because it's like one button on the Atari controller and the joystick. And that's so cool to me. Like, being able to sure, I'll get into robotics. Let's do it. That'll be so awesome. Let me link you the video if you're interested. Hold on. Phoebus linked us the video. This is it right here. We already watched it though, so I'm not gonna subject the other viewers. But check out that talk. That's John Carmack. Yeah, here you go, Swanty. Let me give you that too in that chat. There you go. So yeah, that's what I was saying. If you go back and watch the stream, I paused it like halfway through and I was like, what a living legend, right? So he's already thinking outside of the box. And he's like, they've pretty much solved, training machine learning in virtual environments, but he's literally thinking outside of the box by, building these physical control mechanisms, and, then training the model on that, because there's a lot of things in meat space, to borrow a term from Cyberpunk. There's a lot of things in meat space that you don't have to deal with in a virtual environment. So he's really taking a leap forward with some of this thinking. Oh hell yeah, yeah! Carmack's a fucking legend, man. He's a national treasure. So I'm really excited about that. I got a backlog item to look into it later. It's all down here. There we go. Yeah. Build your own AI robot using Carmack's open source. So it's not released yet, but he's talking about it. He's actively giving speeches and talks and stuff on it. And as soon as it becomes available, you bet your ass I'm gonna be all over that. In the meantime, I'm basically watch that video. You'll see some of the stuff that I've gotten the AI to spit out so far, and then I kind of realized I was using the wrong tools to accomplish the thing that I wanted to do, because the random seed generation on Stable Diffusion, it's got that really trippy look to it, and that's awesome. I can think of a lot of applications for applying that to certain things in videos. but I also need continuity between frames. So that's currently what I'm in the process. And I'm learning Git and Python as we go along. I have a degree in network engineering, so I know how to program like a Cisco switch, but I never learned any coding languages or anything. So it's fun to finally dive in. And, I understand Python's baby's first coding language, but I got to start somewhere. And a lot of the stuff that I'm working on with these AI projects, the stuff that I'm learning in Python is directly applicable to it. And that's going to help me because I got to have an end goal. I got to have I got to have something to work on. And the first thing that I'm going to do when I get all this generative AI set up is I'm going to make some Helldivers 2 in-universe propaganda reels, or a Helldivers 2 in-universe commercial, like a commercial you'd see on TV if we were on Super Earth. Should be a lot of fun. So I'm super excited to do that. It's a bit late. I'm working on this today, but tomorrow I'll throw a couple hours at it after this. I got to do this. This is going to make me money now, and that'll get me through until I can get this AI stuff running, and then start generating revenue that way. All right, so here we go.
That with the latest dump of the binary.
Yeah,
Is
you
that
just have a recipe file, and the commands are streamed down from a control server down to the target device or devices. It's meant to be used in a fleet. Fleet being the word that's kind of taken from like enterprise rent a car. Like
I will say one thing. I didn't have generative AI on my future bingo card. Like I figured we were going to have flying cars before we'd have tools like this. So it's really cool to live in the future. We are living in the future.
Like other fleet
Yeah.
vehicles, right? You got a fleet of devices, and you are pushing out a change to either all or a subset, or like an A/B test group. You push out a recipe change to some set of devices, and that set can be all of them or just half of them or a couple of them.
Okay, that makes a ton of sense. So I can I think you created a very cogent argument for why what you're doing is so much better than the old SaltStack approach. First of all, the fact that it was written in Python, we already talked about like the performance trade-offs of having it written in Python. If it's written in Go and like you're actually doing everything, and then it doesn't even really matter what happens prior to preparing that binary that you're putting out there. It's just that the binary does run, and you can be sure that the binary runs and that it's secure and everything like that before you. Well, I mean, you can't be sure that everything's secure, but to the extent that you can be sure, you can have it ready to go, and then you just deploy it out to your fleet. And as you said, some of these could be like a freaking cell phone, CDMA, or whatever.
Smartwatch, yeah.
Yeah, like devices with low power, with low connectivity. Where you can't necessarily control all the different circumstances, but you can get this out there, and it's just like a much more sensible way of doing it than having to. And so it sounds like those are the main reasons for using something like this. So this is the open source project that you maintain, and my understanding is it's essentially sponsored. Development is partially sponsored by the company that you co-own. And then it's also, you have a few organizations using it and people that donate.
Yeah. So there's some of the more popular, or some of the companies that are interested in having their names on our README are in our README. So we've got a couple of data centers, I think, in France, and then I think Google is using it, and a couple other companies are using Garlic. It is maintained officially by Adatomic Inc., which is the company that I mentioned earlier. I co-founded with Rich, the owner of Cellpoint Systems.
Yeah.
And so we have corporate backing in that sense. That tends to make people feel a lot better. The people that are making the decisions for switching a DevOps platform from something like SaltStack are going to want to see that like Garlic isn't going to just disappear overnight or go away. The other really nice thing in my humble opinion about Garlic is that we've zero BSD licensed, which is a massive sticking point for a lot of FANG companies. I know that Google has like a policy that you're not allowed to use any open source software in your
It has
code
the GPL
that,
or
that is not written by Google, that doesn't have approval from the legal team.
okay.
So
So
GPL is out the door immediately. AGPL out the door immediately. MIT software still requires approval within Google.
really, MIT is considered like
MIT.
I always consider that to be like basically the gold standard of
Well, we all know why that
openness.
is. or at
And
least
and
I
we
do.
use BSD 3.
Yeah.
So you're using BSD 0?
Yeah, so we're using 0BSD. So, and I
Zero
just want to be
BSD.
clear, they'll usually approve it if it's MIT, but it does still require approval.
But what
All
about
open
BSD
source
0?
requires approval.
0 BSD, does that require approval?
No, it does not at all. That's the reason why I ended up going with it, is because 0BSD takes away the only clause that the only two clauses that are in the BSD license. So basically, it just says like, here's some software. You can
Okay.
take it. You can even rename it. You can remove the attribution to all the authors. You can do anything you want with it. Here's some software. Have fun with it.
There's literally no restrictions.
No restrictions
Because
whatsoever.
BSD
Like,
3
don't sue
is
me.
basically, we just don't want people to like, oh, okay, so it's just don't, I'm not going to be held liable.
Like, I say don't
That's
sue
the
me,
reason for
but
using this
it's
as
not
opposed
really-
to not having any sort of license.
Yeah, and then
guess
I do maintain-
yeah, go ahead.
Yeah, and I do maintain copyright over the word garlic and over the mascot. We got a mascot named Clove. I'm actually wearing him on my shirt right now.
So it's like a gopher with like just verbally describing it. It looks like a clove of garlic.
Yep, it's clove of garlic with the go for eyeballs and nose and mouth. So yeah, I maintain copyright over garlic and over the mascot Clove, but otherwise the code base is 0BSD, and it's not really because I want people to take the code base and run with it and like rename it and then go make $1 million off of it. Like, if you do, please send me a check. But it's more just to get over that legal hurdle.
Yeah, I mean, that makes
and
great
make
sense.
adoption easier. Yeah,
Yeah.
because my main customers are going to be people that have fleets of devices. That's not going to be like users, right? It's going to be companies that are making a decision on, do we go with this system or that system for tens of thousands of devices? Because that's where garlic really shines. So if that's my audience, I need to make sure that I'm not introducing additional legal hurdles for them. Now, if you want support, like, a service contract, you want support, then you can pay money for that. That's part of the reason why we have Adatomic.
Yeah.
Is we can sign contracts through Adatomic for, windows of time that you want allocated to you, response time, all that sort of stuff. If you want us on call, and then additionally, Garlic is shipping a plugin system. So Garlic by default requires no plugins and requires no dependencies. That's like a huge selling point of it. But there does come a case where building everything into the main binary will increase the bloat of the binary unnecessarily for people that don't need all those features. So we have in the works a WASM plugin or WebAssembly plugin system that allows you to do things like connect to an LDAP server, or connect to allow you to do more fine-grained role-based access control rather than just users and groups, which is built in. If you need to hit like a certain storage backend, like we built in, we support pulling files from S3. We support pulling files from FTP, from SFTP. We support pulling files from all these different backing ends, HTTPS, FTP. But if you need to pull it from like a Google Drive, okay, that's going to be a plugin, because that's not something that most people are doing in their deployments.
So essentially, like you'll build plugins for hire.
Yeah. So
Like people can give you a bounty. Like they can be like, "Hey, I would love for this to have Google Drive integration," and then you can be like, "Sure,
Exactly,
I can make that
exactly.
happen."
So we offer
if
that
you
as well.
can Essentially, like offset me for the development cost.
Yep, exactly. So that's those are our two monetization strategies: are the service contracts for support, and then feature prioritization on the plugins. So we're mostly focusing on WASM. I've been doing some exploration recently on Shopify has a Golang implementation of Lua. So adding like a Lua plugin runtime as well. But that's not promised yet. That's not really on the roadmap yet, but I've just been evaluating it to see if it's worth doing.
Okay, so what I'd like to do is kind of generalize out the advice that you have here, how you've approached this. So if I can make some observations. One, basically do everything to simplify adoption by the kinds of companies, like if you're doing like fleet, computing. I can't remember the exact term you used, but essentially just like huge arrays of different devices that are maybe really small devices that don't necessarily have like a whole lot of onboard memory or onboard storage or something like that, where just having it be extremely efficient is really important. Yeah, like I know you said the company that you work for has like Cell in the name of it. It's like a cell phone tower type company or something related to cellular.
It comes from that, yes.
Yeah.
Initially, yeah.
So like would like a huge kind of like fleet of cell towers, and would that be like a potential use case, or like CubeSats, or like what kind of devices are we talking about when we talk about fleet devices? Internet of Things.
We're talking like mini PCs and display controllers for the most part, in terms of Internet of Things. But Garlic is not really geared specifically towards IoT. It will work really well with that use case because that's my main background. But I also have a large background in doing cloud VM server deploys. And actually, just behind this door here, I don't know if I could open it, but I've got a giant baker's rack full of just Intel NUCs, just like rows and rows of them that I do stress testing on for
Very
Garlic.
cool.
So we have I'm running probably 35, 40 different machines just on the other side of the store.
I don't know if I can open it. Could you try? I'd love to see it.
Why don't we hold that for the end and we could show it later, because I don't want to
stay to the end.
edit it out.
If you're watching the video version, if you're watching the audio version, I'm going to verbally share everything that I'm seeing. So just to finish what I was recapping before I went off on that digression of use cases, like who use this, but essentially using the zero BSD license to make it really simple for Google and other big tech companies to adopt without having to take up their lawyers' time getting clearance, making sure that it's totally free, totally open source, that people can do whatever the heck they want with it. But the goal is not to sell the software. The goal is to sell services that support the software in the sense of feature prioritization and in terms of actual contracted support. A lot of people do not want to just grab some tool off the shelf and not have any support and like essentially rely on their own engineering team to go and debug and fix things. They want to have the actual people who built it who can help ensure that like everything's going smoothly, and that's where like service agreements come in. So what you are essentially doing is free open source software that has dimensions that make it sustainable. You're not doing this out of the goodness of your own heart necessarily. Like obviously you're probably doing that, that's a big part of it, but you're also wanting this to be a sustainable long-term operation, so you've kind of baked that into the proverbial business model of this open source endeavor.
Yeah, exactly. I mean, it's going to be a while before it's something that can be sustainable on its own. Rich and I have put a considerable chunk of money into it, not just into not like ignoring my development time completely. And I think Garlic's been around how long now? I don't even know. It's been
like 5
at
or 6
least 3 years,
years,
maybe.
yeah,
It's been years. I don't know when version 1 was officially published. Version 1 might have only been published 3 or 4 years ago. Or the first public commits, but it's been in the works for 4 or 5 years. And then, we've spent money on marketing, t-shirts, conferences, all sorts of stuff, trying to meet with people that are in the right space on this. And I would say that's probably where we've had the most success is, we go to, or at least I go to GitHub Universe every year. And I go and I meet with the vendors, and it's really important to be respectful of their time because they're there to sell other people on stuff. And then I'm trying to sell the people that are paid money to sell stuff. So it's more just like a quick introduction and like, hey, can I talk to you later? I'm not going to pitch it right now. I'm going to talk to them and say, hey, I've got something that would work really well with your service. Can we set aside some time to talk about this when you're not on the floor right now talking to other people? Because they paid money for their ticket too.
Yeah,
you got to be respectful.
It costs a lot to have a booth.
Oh yeah,
and to be an exhibitor costs money, and you're there to.
You should know, right? Haven't you had one with Free Code Camp a couple times or no?
We always get, because we're a charity, they'll just give us
for free.
Yeah, but we're not trying to sell anything. We're just raising awareness of like the various open source endeavors within Free Code Camp. But okay, so that's useful, actionable kind of sales advice. Don't be mindful of the fact that those people are there with a different mission, and just kind of step in, introduce yourself, and then that's a warm contact. When you follow up later, they're gonna be like, oh yeah, I'm that guy that dropped by, and here's what I was talking about here. Or can we meet and grab like lunch, after like the exhibition hall closes or something like that? Or I guess it wouldn't be lunch, but like,
Yep.
how do you like? I guess a lot of these companies are in the Bay Area, so it's not. You're in the Bay Area, so it's not out of the ordinary for you to like drive or take the BART or something to Caltrain to go meet up with somebody in like San Bruno or something like that, wherever they happen to be.
Yeah, I mean, I've actually been doing a lot of it over the phone. I've had better success with that than driving out to meet with people in person. And I think part of that is just, for the types of partnerships that I've been going after, people have really seen it as more of a partnership than either one of us selling the other on something. I mean, it's been good for everybody on both sides, because I can look at it in terms of like, okay, well, maybe I'm not going to get a service contract out of this, but I've got another user and I've got someone else who's excited about this because it's an exciting project.
So you've got kind of like a range of like possible outcomes, and just getting a user
Yeah.
is still a win. Getting a service contract would be like the best potential outcome.
Yeah. Yes. I mean, the when I get another user, because of what this software is and what its role is, a user isn't one computer running Garlic. It's going to be hundreds or thousands. So the number of compute minutes that Garlic is running on different services, I mean, ideally it's low per system, because I'm trying to maintain, low resource usage and everything. But the number of runtime hours that Garlic gets, I see that as a nice metric to go for. And being zero BSD, I have no telemetry, so I rely on people to tell me that they're using Garlic before I know. There's a community Discord, and it's people start pouring in and saying, "Hey, I've been trying it out. I like it. I don't like it. Here's what I don't like. Here's what I do like." And then we take the advice under take the advice under consideration. There's no telemetry or anything though, so other than on the Garlic website, like the docs page like has like a post hog integration or something. So I do see people that are visiting the docs, but the binary itself doesn't do anything like that. So yeah, I mean, there's plenty of things that would get me excited. If someone's just using it, that's nice. Service contract, of course. Like, I'm not going to say no to money, but yeah, I really want to get Garlic to become like. I guess household name is the wrong terminology, but
yeah,
like,
because it is
like
a very
household
specific
name.
industrial tool. It's
Yeah,
like
yeah.
like I don't know, like CUDA isn't necessarily like a household name, but it's very
Yeah.
important.
Yep. So I want to take on the market share of, Salt Stack, Ansible, Puppet, and Chef. Like I want the list to be Salt Stack, Ansible, Puppet, Chef, Garlic. Like I want, and who cares what the order is, but I want to be on that list with
Being
everyone,
on that list
with everyone
is a
else.
huge win. So
Yeah.
even being in that room is an accomplishment in itself. Okay, that is helpful context. I want to talk a little bit about your consultancy and like how you've been training junior devs and essentially prepping them to ramp them out to do client work. Can you talk about that a little bit? Because I think a lot of people are going to be interested. First of all, a lot of people listening to this would like to enter the market as devs. And I must say you're in the right place. This is precisely the kind of thing you should be doing with your time if you want to become a dev, is learning from people like Ty Groot, who've been out there in the proverbial mines, getting things, bringing things up to the surface. Can you talk about that kind of approach that you have discovered over time, and like what you've learned from bringing people on, teaching them, and getting them ready to work with clients?
Yeah. So in addition to SolvePoint Systems and Atatomic Inc., I also have my own single member LLC. It's called Tiger LLC. I ended up filing an LLC primarily just so that I could get an office building, so I'd have a place to really focus and work. It's like one city over from where I live. It's not too bad of a drive. It's like 10 minutes. And I just wanted like a space to get, like, I have tons and tons of equipment here. I've got like 3D printers and multiple machines. And like I said, a baker's rack in the back with, a couple dozen systems. So I filed an LLC just so I could get like a I don't want to call it like a creative space and sound like like all hoity-toity and everything, but like I need some place that I can sit down and like this is the place for work. And so I filed an LLC, and then not long after that, a friend of mine, his name is Scott. He and I work with a lot of the same clients. Just consult. I was consulting as an individual before that, but he and I were working with a lot of the same clients. And we kind of realized like there's a lot of work here that isn't necessarily boring work, but it also doesn't require us to be firing on all cylinders just to get it done. So it's not really like tedium, but it takes a long time, and we're using maybe 30% of our capacity as developers to build some of these features that we need. So we started looking for like, okay, is there anybody that we know that we could kind of hire for this role? And the answer was like, yes, live in the Bay Area. Everyone here writes code. Not really, but it feels like that sometimes.
Yeah, I mean, when you walk into a cafe, everybody's got freaking VS Code.
Yeah. You're at a bar and someone's got that's me half the time, so I should pay attention to who's talking. But you walk into a bar and there's a split keyboard out. But it's like, okay, well, everyone here writes code or knows something about code, or could potentially fill the role that we're looking for. The problem is the cost of living here is super high, and a lot of our clients aren't here. Like, so they don't have that cost of living baked into all their expenses. They're not expecting to spend as much on a developer. They're not expecting to hire somebody at $250,000, $280,000, $300,000 a year. They want to hire somebody or get work for somebody at an hourly rate that would convert to something closer to 70, 80, 90. And that's not a bad wage, right?
Yeah, not outside the U.S. In California, it would be pretty difficult to live on that, but
California, it's tough. Yeah.
In the U.S., like where I grew up, Oklahoma City, that would be like perfectly respectable. Like you'd be like pretty well off if you could make like $80K a year. But then if you go overseas to Europe, or to Asia, or to Africa, like suddenly you're like the richest person basically, with a wage like that in some places.
Yeah. So that kind of made me shift our focus to like, okay, we can hire somebody, but then the client wouldn't be able to afford them, and they already can't afford us. Like, there's stuff that they want to do, but they're like, oh, but maybe we'll do it later. Like, we can't really afford to do that right now. That's the kind of situation we're working with as well. So we're like, okay, instead of hiring somebody from the Bay Area, maybe we can, expand our horizons a little bit, not look for somebody here, and instead we'll look for somebody that's, somewhere else in the United States. So the first contractor that I brought on is actually from, let's say, Central Time Zone, right?
Okay.
So south of Kansas and Central Time Zone. We'll put it like that.
Okay.
And she's somebody that I knew in childhood, and she's was in that same computer science class with Jason Parker that I took in high school. She was a year ahead of me, but she was in the same class. So I kind of knew that she would probably have a somewhat similar background to me on some things. We were on a robotics team together in high school as well. So I knew she kind of had a mind for problem solving and for asking questions. And that for me, I don't think I'm being original when I say this, but I think that for me is the most important thing, is not what you know today. It's more your mind for asking questions and learning new things and figuring out the right way to do something.
I'll co-sign that.
So
that has been my experience
way more important than how many years you've been writing a language. Because the person who is interested in learning the tooling, learning how to do something correctly, and constantly asking those questions and upskilling, is going to be able to pick up a language faster than, like, pick up a brand new language and be better than you at it than someone who's been writing it for, writing the same language for 5-10 years. Because it's like a mental and like a personal evolution over time. You just keep upskilling and getting better.
Acceleration overtakes speed.
Yeah, absolutely.
That doesn't actually make any sense, but that's what I mean. Like if somebody's going like way up here and you're going like this, will eventually overtake them if you're working on it.
Higher order derivatives for the win. Yes.
Yeah.
So I reached out to her and asked, like, hey, what are you doing these days? Are you like, where's your work? Oh, I just finished school. Oh, was it a computer science degree? No, it wasn't. It was, I think wouldn't mind if I say I haven't said her name or anything. So she actually graduated and finished school, pursuing a nursing degree. She had some electives that she had done for networking and database management and a couple other things because
Yeah, I didn't want to comment on anybody's appearance, but I was like, man, these guys could be brothers. Look at that.
it was always an interest, but that wasn't the degree. Those were just like electives, as far as I'm aware. And so I ended up saying, hey, well, what is your what's your job prospectus where you're at? And she kind of talked to me a little bit about that, and I was like, okay, what if I paid you double that? And what if you could start working with me like next week? I've got a client that has such and such budget. And I shared all the numbers with her. I was very open on like what the client could afford, what the client could pay, what I would keep in the middle, all that sort of stuff. I try to do that with everybody that I bring on.
Yeah, that's really chill. I think that's a good, because then you don't ever have to worry about them finding out. Oh, like,
Yeah.
or like cutting you out.
Yeah,
That's
exactly.
another thing is that you have to worry about when you're kind of like a middle man, for lack of a better word.
Yeah, exactly. And I've dealt with that at another company in the past, but that's a side story for later. So I said, okay, great. She was up for it. Said we would give it a try. Great. And I said, okay, here's the thing. You've not written code professionally ever, and you've not actually this will also be like her first like real job outside of whatever she might have done in high school that I don't know about, right? So
Well, if I was still a spring chicken and had a full head of hair, I'd still be clean shaven. But I think. Well, I don't know. I'll have one of these days. I'm sure I'll shave the beard because I need to do it for like makeup or a costume or something like that. And then we'll see what I look like just like Mr. Clean. I might like that look more, but I'm not ready to let it go just yet. We'll let this grow out a little bit more. I'm going to stylize it the same way I had it when it was really long, but I'm going to make this straight line like down here. It's got to get a little bit longer because it's a little curly. So I got to get it long enough I can straighten it. So maybe like another 3 months and I'll straighten it all up so it's all like straight down here instead of down to here. And we'll see how that looks. And then hopefully by then all of this stuff with this side hustle works out and I have spending money again and I'll be working on video projects.
So I was like, okay, here's what we got to do. Before I feel comfortable handing you over to a client.
Oh yeah, I got
saying
pictures
she's
of
going to
that
bill out at
Matrix
this
costume
rate,
in my car.
get these things done, go for
In
it,
Florida.
and then just kind of like leaving her to be, like leave her to the wolves. I actually spent the first 3 months bringing her on, going through all sorts of onboarding and training. And so what that meant for us was I wasn't exactly sure which projects the client was going to prioritize. And like any, end customer, they're going to need front end and back end code. Like you can't have a company these days without having a website, really. And they're selling online courses. So that's like a huge part of their business is their website, right? There's also a massive part that's to the back end, like tracking registrations and who's coming and going and which classes are you taking, which classes get canceled, do we sending out transactional emails correctly, all that sort of stuff. There's like a massive back end to this as well, and a headless CRM interface, all sorts of other customer relationship management, and a CMS, a content management system as well. So we've got all these different like bits and pieces that are built and running in the back end, and then we're told by the client that they have these tasks and jobs that they want done that they can't afford to pay us at our current rate. So I am now in the position where I have a developer that can make this the correct rate that the client's willing to pay, but I don't really know what their priorities are because they didn't tell me yet because in their minds they can't afford anything. So I ended up training her full stack, We went front end, back end. We did data transfer back and forth. We built a small little app called Bridge Time, which will probably spike in traffic after this, which is just for like if you've got a friend who said, oh, just if we have one of our mutual friends is very macabre in his sense of humor, and he said, if I ever forget how to tie my shoes, I just want you to put me in a wheelchair and huck me over the side of the Golden Gate Bridge. So we made Bridge Time based on that. It's like you can put in like if someone breaks a promise or says that they wanted to do something or whatever, that type of agreement, it's like a joke. Then you send them the link when they do the thing, and there's like this little animation that plays of a guy wheeling someone over his side. It's all pixel art. It's not graphic or anything. It's just funny. So that was a joke site that I wanted to do for a while. So as part of our onboarding, I actually sent her a whole bunch of free code camp videos from the React track. They're some of the older videos now. I think you guys have reshot a couple of them. I saw one of them came out again 7 months ago. Yeah. This would have been a while before that. And basically gave her a starting point where she could work on. And that was a really good foundation for her front end track. And then from there, I kind of brought in some of my knowledge and some of my expertise using, Next.js and a couple of other, more meta frameworks for React. Basically said, okay, the free code camp video shows vanilla React. Here are the different things that you have to change to apply this to a Next.js code base. And then we kind of carried on from there, and she built the front end for that. And then we moved on, and she actually took some courses. I paid for her to go through boot.dev, which I know you're familiar with them as well.
Yeah, I've had their credit on.
Yeah, and I'm friends with Lane Wagner as well. I don't know if you would call us friends. I'm acquaintances with Lane Wagner. And I sent her through the Go backend course, and then she kind of filled in some other backend stuff as well. And then we built a backend in Go using just SQLite hosted on a $5 VPS. So that whole site, she built everything there. I made some tweaks and changes and kind of gave her advice and nudged her along. But basically, I used some of these resources, and she's also, like I said, a very self-driven person, and that's the most important thing to me, is that you are willing to put in the work, and that I'm more than happy to lend a helping hand and point you in the right direction towards the right tools. So that was the first person that I contracted with. I've got a second and a third person that are kind of going through the exact same thing. The third person, we're actually giving him some assessments and tests right now. He's out of Poland. And so, yeah, just kind of trying to slowly build this up over time, and bring different people in.
So you're not just going out there and trying to find talent that's already on the market. You're actually bringing new talent on the market, and you're also helping kind of like nurture that talent and provide guidance. Like you mentioned, like, here, build this project, here, take this course. And so you're kind of giving them like a curriculum that you think is best suited to whatever the work that you have on hand that needs to be done, because you have kind of like this lead time in terms of your client's going to want this. And at this point, you find somebody, you're like, I think this person can do it. Like, I think they have kind of the raw input that's necessary in terms of like the curiosity, the problem solving skills. They have enough exposure to programming and software development concepts that I think that within whatever period of time that you have available, you will be able to get them up to speed. And you actually put your money where your mouth is. My understanding is it does cost some money to pay people essentially to learn and give them kind of like a paid internship almost, or a paid apprenticeship, if you want to call it that.
Yeah, it's probably 3 months of full-time pay, that I'm not actually billing a client for that time, right?
Oh, hey, Deathforge. Yeah, a little bit. I'm just sticking my toe in the water with the Python stuff, right? So, like, I mean, I've got a degree in network engineering. I know how to program like a Cisco switch, but the Python's baby's first coding language. So these guys at the beginning were talking about that, the strengths and weaknesses, and this has been a good conversation to be a fly on the wall for. The real shit though. I was just talking about it. So we finished watching that talk by Carmack, and this motherfucker's already thinking outside of the box. So most of the AIs have been trained in a virtual environment. But he's like, well, okay, we've already solved that problem because we are successfully training models in machine learning in virtual environments. In fact, they've been doing it in a stripped down version of Quake 3 that he wrote in the first place, right? But that's completely different from moving an Atari controller around. So he's currently in the process. There's an apparatus that is built that moves the Atari joystick around and pushes the one Atari button, because the Atari controllers only had one button. And it's you're teaching the machine learning to watch the screen and to move the joystick around. He's going to make all this open source. And I've always wanted to get into robotics. So guess what? So as soon as I got some spending money, actually as soon as it's released, it's not released yet. So it's a backlog item. It's in the ideas phase right now. There's nothing out there yet. There's no white paper. But he's actively giving talks on it. So that was the other cool thing from checking out this video. And now these guys are just kind of wrapping up. And I got about another 15 minutes in me. I'm working on a side hustle. Just reading through this book. It's completely doable. It's all above board. I just got to research a bunch of different stuff because it's based on state law. So there's a couple of states that'll be more advantageous to work for or work in than the other ones. But my roommate and I are going to dive into this. He bought this book and I'm diving through it. I've got my project manager hat on right now. I'm taking a fuck ton of notes. And then I'll be spending a few hours on this each day. Then we'll move over to, some of the video /channel /AI stuff. And then we do some gaming when my brain can't take it anymore. So like I said, I got like 15 more minutes in me, and then I'll call it for the day. I also applied to another 5 jobs today. And then tomorrow, I got to file some more claims with the state of Florida. The sons of bitches owe me like 2 months worth of pay at this point. So, whenever they get around to processing my claims, everything's going to be fine. But they're moving at the speed of the government. So, I'm not counting my chickens before they hatch.
And then in addition, I also, we use pull requests for everything.
Yeah.
It's all of our developments through GitHub. So every code, every piece of code that comes through, I end up reviewing it before we merge it for the client.
Oh, yeah, if you go back and watch the live stream, you'll see, like, I'm pausing it and I'm like, Carmack is a living fucking legend. I mean, oh man, Oculus, Doom, Quake. He was the first guy to develop mega textures. I think it was ID Tech 4 used mega textures. So it was the first time like you could see a really big landscape that didn't have textures stretched out all over it. I think it was Quake Wars was the game. Phoebus remembers Quake Wars, don't you, Phoebus?
Because they're a real business. They want high uptime, right? If the site goes down, people can't purchase things, they're losing money. So they need to have good uptime on everything.
Yeah.
And part of that's the tools we choose. We're using like a durable job system. I think we're using Temporal for a couple of different things. And then part of it is just the code review aspect too. And it's gotten easier and easier for me working with the contractors over time because, when I know what a certain change is going to entail, I can just kind of give it a quick glance and say, yep, that looks basically about what I would expect. And I can just merge it. And then, for some of the newer features, I was up till midnight or 1 a.m. last night working on something for a new feature that was kind of out of the general realm. We were trying to get a Postgres database dump built into a DigitalOcean app platform worker, and it turns out it's not possible. But I had to prove it wasn't possible, and that took many hours first. So anyway, at least not in the way that we were trying to do it. So
yeah. Well, it sounds like between your consultancy work, Adam. What is the name of it again? It's Adatomic.
So my LLC is Tiger. Yeah, Tiger LLC, Adatomic Inc., and then Cellpoint Systems.
Okay, and Cellpoint's your full-time employer,
Yes.
and then Tiger is your own personal consultancy, and then you're co-owner of Adatonic. And I just wanted to share this word because I didn't know what it meant. I was like, what does that mean? So Adduction is where something doesn't get like absorbed or adsorbed. I don't know the term. I'm not a physicist, but essentially, you can like an atom maybe resting on a surface and not be like absorbed into it like a fluid, and so that atom sitting on top of that surface is kind of like poking out, essentially protruding at like an atomic level. So it's a very minor protrusion, but essentially that's what adatonic means. It means kind of like adhered to or stuck to something else.
Yep. My chemistry background from that I almost went down that track coming back here at the last moment, right?
Yeah, very cool. So you got to open the door. I want to see what's behind there.
All right, we'll see, but we can't. We might have to cut it. I don't know what the camera will be able to see back there. So,
okay,
all right,
let's try
see.
it. So
We go to the other side.
I will narrate. We can't. Ty's not near the mic, so he's not going to be able to say what he's doing here. But essentially, he's gotten up out of the seat, and I want to remind you, we don't edit this podcast. This is unedited, so I'm just filling dead air here. I'm not going to attempt to tell a joke or anything. Looks like he's opening the door. The door is opening. It's a big wooden door. I can hear things being moved around. The door is opening. Whoa! Okay, so he's moving his chair. Wow, I can see. So I see a bunch of racks, and I see a lot of Cat 5 cable. It looks like.
The screen is not capturing everything. There's another two or three racks above the border.
There are
of
2 or
the
3 racks
here, but...
above. But imagine like if you watch like Die Hard with a Vengeance, like the bomb scene where they're defusing the bomb. Like that's basically what it looks like back there. Just a whole bunch of cabling and a whole bunch of small devices linked together. But that was very cool. Thank you for opening that door, Ty. Now everybody who's curious about what's behind that door, you can't show somebody a door and not open it, right?
Yeah.
Yeah. Awesome, man. Well, it's been an absolute blast learning from you, talking for you for the past 2 hours. I learned a tremendous amount about the various trade-offs associated with those different programming languages: Go, Rust, TypeScript. I learned a lot about the Linux kernel that I didn't know in terms of just how, like, I guess, tight it is in terms of like the extreme requirements that people have for code that gets submitted, and also at the same time, I didn't realize that like device drivers were just dropping huge blobs of C code from the air, and then they were having to get merged in, and it's kind of like, like the distribution of, I guess, accountability for different things in that world. But it's so cool to talk to somebody who's in the open source world, who's like touching on so many of those different things. What is some parting wisdom that you have for people who've made it this far into this podcast in terms of people who would like to ultimately do what you're doing like the hardcore back-end development, working with maybe like underpowered hardware, huge fleets of devices, and being able to essentially get as much runtime on as many devices as possible if that's the metric they want to optimize for? What should they do?
This is going to sound silly because it sounds like I'm just copying the meme, but seriously, use Arch Linux. For real. And don't go through the new Arch install script installer. Like, it's really important to understand how all of your system works, like top down. There's plenty of YouTube videos out there now, tons of educational material on how Linux works. I've built a Linux from scratch system. Everything sounds much harder and much more complicated than it really is. Linux is not hard. I've got working audio on Linux. This whole podcast has been recorded on working audio drivers on Linux.
Wow.
It's audio and video, right? I think out of everything that I've done, the fact that I'm running a daily driver computer that breaks on me once every few months is actually what's driven me to figure out why things break and figure out the real fix as opposed to a Band-Aid fix on top of something. So the number one thing is, and Arch Linux is kind of a joke, but like, dig into how your computer actually works. Figure out what's actually going on, either when you write code or when you click a button, like everything from writing code to clicking a button. Figure out what you're doing is actually doing on the CPU, what it's doing in memory, and what it's doing on your file system. That's, I think, the most important thing. To understand things at a higher level is understanding them also at a lower level.
Awesome. What a great note to end on. I'll just mention that we do have an Arch Linux handbook that was published by Farhan Chowdhury, who's a prolific FreeCodeCamp contributor. You can check that out if you're just looking for a good Arch Linux starting point. So just like grab some random PC that you haven't used in a while and install Arch on it. I mean, is that like that?
Yeah, and even if you don't use
Free
Arch
what?
Linux, the Arch Wiki is still one of the best sources.
Ran for Chowdhury, who's a prolific FreeCodeCamp contributor. You can check that out if you're just looking for a good Arch Linux starting point. So just like grab some random PC that you haven't used in a while and it's starting point.
Free what?
So just like grab some random PC that you haven't used in a while and install Arch on it. I mean, is that like that?
Yeah, and even if you don't use Arch Linux, the Arch Wiki is still one of the best sources of information. The Arch Wiki, and I've heard the same of the Gentoo Wiki. Figure out what you're doing is actually doing on the CPU, what it's doing in memory, and what it's doing on your file system. That's, I think, the most important thing to understand things at a higher level is understanding them also at a lower level.
Awesome. What a great note to end on. I'll just mention that we do have an Arch Linux handbook that was published by Farhan Chowdhury, who's a prolific FreeCodeCamp contributor. You can check that out if you're just looking for a good Arch Linux starting point. So just like grab some random PC that you haven't used in a while and install Arch on it. I mean, is that like that?
Yeah, and even if you don't use Arch Linux, the Arch Wiki is still one of the best sources of information. The Arch Wiki, and I've heard the same of the Gentoo Wiki, but the Arch Wiki will almost always have like an answer or someone else who's had that. So when it finds those lines of JavaScript in the future, it will just jump directly to the precompiled set. So going back to what I was talking about with Python, it's one of those trade-offs where for a short enough program or a program that you're only going to use once or twice, doing something that's like interpreted or just-in-time compilation can actually be faster than sitting there and pre-compiling the entire thing. And the proof of that is every time you load a web page, the interactivity, if the web page is built correctly, the interactivity loads basically instantly. And it would take much longer if you were waiting for a pre-compilation step.
Yeah. Okay, so I'm going to recap some of what you said. First of all, JIT compile just in time, just like just in time production. If you're familiar with like manufacturing or something like that, you order a part and they custom, make it just as a one-time part, as opposed to having like an entire production run, create hundreds of parts, hundreds of copies of that part. It's like here's that one part that you needed. So that's where the term just in time was imported for software development is from manufacturing. So just-in-time compilation, V8, this JavaScript engine, again, maintained by Google, and I think used in Chrome, and of course notably used in Node.js, which the FreeCodeCamp curriculum uses as the primary way to do full-stack JavaScript. And of course the creator of Node.js also has Deno, which is basically like a kind of a SQL project that addresses some of the shortcomings of Node. But if you've heard of either of these projects, what's really powering them is V8. And the true power of V8 is, as you said, the ability to notice repetition within a code base and just cache the output of that like function or of that loop so that it doesn't need to keep running it over and over. And that's how it can be so high performance, even with an interpreted language like JavaScript. And Node.js is famously extremely high performance, which is surprising considering that it is based on an interpreted programming language. So let's talk a little bit about Go and Rust, and we can talk about TypeScript too, which is basically just JavaScript with types. That is a little it's type safe JavaScript, so it just dramatically reduces the likelihood of bugs. Type-based bugs, my understanding, are extremely common. And it's one of the most common kind of things that can go wrong. So if somebody threw up their hands and said, JavaScript should just have static types, what the heck? And so they created TypeScript. But if you know JavaScript, you can very quickly learn TypeScript. They're practically the same thing. It's just, my understanding is it's just a little bit of additional functionality built on top of JavaScript. Does that jive with what your understanding is?
Yeah. So there's kind of like a straight line that kind of goes from like your Python and your JavaScript languages through your Go language through to Rust, and it's kind of like a timeline and in terms of how easy is it to write and versus how performant is it going to be, and also how long is it going to take to compile. So one of the kind of the through lines you'll notice is that the more performant a language is at runtime, usually the higher cost it has at compilation time. So something like a C or a Rust are going to be around the same. C++, Rust, C++, C, and Rust are all going to be about the same. Now, C++ has just about the worst compilation time for a programming language that can build a program of sufficient difficulty or sufficient complexity. And that's because C++ really likes to import a lot of header files almost recursively, like over and over and over again. So really the problem with C++ compilation time there is not the code itself, it's more the header language, like the meta language, the macros that you can use up above that change the behavior of your code based on different compiler targets. Because you'll have library A that imports library B that imports library C that also imports library A, and you have like all these different like import cycles and everything, and the compiler needs to be able to handle that just because of so many years of legacy. And so that was part of why Go came into being. Was again the compilation time of C++ is so slow that they're like we need something that's faster to compile at least than this. And while we're building that, why don't we try to come up with a language specification that is going to give us a language that's really easy to write and it's really fast to onboard new developers to, while maintaining that we need to make it high performance at runtime so we can't have another interpreted language. So Go kind of fits much closer to Rust than to TypeScript on that through line. And certainly much closer than Python. So starting back over at TypeScript and JavaScript, like I had said earlier, being interpreted languages, there's always going to be some sort of slowdown to that compared to a pre-compiled language. Now, like I said, there's a price you pay in compilation. That's a one-time cost that you pay for execution. So if you're going to execute this program twice, 3 times, 4 times, is stuff running in production? Is it running? Are we now talking? It's not just a shell script that runs top to bottom and then exits. Maybe it's a service that's running long term. Well, keep in mind that cost is going to be accruing over the runtime of the program, not just a one-shot execution through func main or the main function. So a lot of the gains that you get are actually going to be towards more server-driven applications than for command line tools. There's a huge boon of command line tools that are written in Python and TypeScript, and they're all perfectly fine, right? They'll run through, and as a developer, you might be running it a couple dozen times a day. I think there's like some command line utilities for accessing AWS resources. I think the AWS CLI, I think that was originally written in JavaScript. It might be in another language now, but yeah, there's a lot of command line utility programs or CLIs will all be written in Python and JavaScript, just because the speed of execution isn't anywhere near as important as the developer's ability to make quick and easy changes to the code, or to test things using the like I said earlier with like the Jupyter Notebook kernels. You pause execution and do some more advanced debugging at runtime. Types added something really interesting to both Python and JavaScript as interpreted languages, because neither of them actually are used. And what do I mean by that? So in a language like C++ or Go, you've got, or especially Rust, you've got a type associated with every piece of data. And so every piece of data that you have has a shape to it that's part of that type. So if it's an int, like an integer type, you know exactly how many bits in memory or how many bytes in memory are going to be set aside for that type. And if you define a struct or
this far into this podcast in terms of people who would like to.
Okay, I don't understand how we backed all the way up to that. I wasn't paying attention. I was doing my research for this side hustle. I'm at a stopping point. I'm sitting over here yawning. I'm getting tired. See? Is it contagious? Did you just yawn sitting there? at home watching this live stream. That's how we're connected, through our need for sleep. Okay. I am going to be AFK for about 5 minutes. I'm going to get something to drink. I'm going to see if the roommate's back yet. He went to go visit his girlfriend in the hospital. Poor thing's got cancer, and she's getting radiation treatment. And it's like serious enough. It's like the serious dose. Like she ain't going home. You know what I mean? Like she's staying in the hospital. So, I feel for anybody going through that. He might be back. So it's my job. He bought the book. It's my job to put my project. It's my job to put my project manager hat on and figure all this stuff out. And this is so doable. This is a really good book. It's nice and succinct. It's not superfluous. I'm on page 17. I got 60. Well, that's just a checklist. I'm making checklists as I go along. Okay, I got 55 pages to go, and the rest is checklists, and then a notes page. Okay. And then the good news is I'm already familiar with a bunch of technology that's going to help streamline a lot of the customer interaction and documentation, as well as a safe vector for submitting legal documents like a picture of their social security card or their driver's license or something like that. Because I built a bunch of stuff for the fintech company that I was working for using it, and we can use it for our own personal business. So I'll probably be done going through this book in the next day or two, and then I'll probably need to spend a couple of days working with my roommate to get a couple of things up off the ground. But it's basically, what do we call the company? We can't name it anything flashy because we don't want the government people we're talking to be biased against it. We don't want them thinking it's some sort of a scam or something. That's basically it. And then it's not going to cost the person any money up front. The people that will be helping, it doesn't cost them any money up front. We only get paid when they get paid. It's not a fucking scam. This is all above board. I've already done some independent research on it. There's no reason I can't be making some revenue off of this in the next couple of weeks. There's no reason whatsoever. It'll only because my soft skills suck, but my roommates do not. So he's really good at cold calling people. He worked in sales before. I have never worked in sales, and have never wanted to because I'm not good at cold calling people. But I'll learn from him, I guess. Oh well. All right, let me. Did you ever cover what the side hustle is? Yeah, it's an unclaimed funds business. So let me explain it. Like, all right, so government seizes a property because overdue tax on said property, right? They seizes it from somebody. The government hosts a public auction to recoup the taxes owed. Overdue taxes owed is $10,000. The property sells at auction for $34,000. The government pays itself the $10,000. There are now $24,000 in excess funds, also known as overbids, overages, excess proceeds, or surplus funds. The owner of the property is supposed to receive those funds, but they rarely do. The government is obligated to notify the individual owed only once. The former owner often moves without a forwarding address, so the one legally required notice of the overage is sent to the last known address, the address of the property that was just taken out from under them. And after these monies are unclaimed for a period of time, the government claims them. So, we basically call up people like, hey, remember the government stole your house from you? Yeah. Well, the government actually owes you $30,000. Go to my website, sign here. I get 10%. Okay. Okay. What I don't owe you any money from? No, I get paid when you get paid. Sign the agreement. That's it. That's the business. That's the business. That's all it is. It's above board. I can't. There's
There's people there are 20 somethings making 5 figures a month doing this. So I want mine. I'll be back in a minute. That is fucked. Oh, are you talking about the unclaimed funds thing? Yeah, it is bullshit. Oh, here, let me show you. Yeah, helping people get their money back from the government. It seems like a worthy calling. Give me 10%. Government owes you $24,000. Give me 10%. We'll get it for you right now. Go to the website that I just built. Oh yeah, I know how debtors work. If you don't pay your bill, they after a certain amount of time they write it off as a loss, and then they sell your debt to somebody else for a fraction of the cost. And then if that person doesn't get the money from you, they sell your debt off to somebody else for a fraction of that cost, and then you end up paying the debt, the full price of the debt 5 years later. Somebody paid $5 for your name on a list. Yeah, I know how debtors work. No, but this is above board. I wouldn't be doing it if it was fucking people over or something. I simply would not be doing it. You know, getting 10% of me taking 10% of money you didn't even know you had seems fair, especially when I did all the paperwork. Shit, I should be getting 20, but I'm not a greedy man. And I'm just giving you back money the government owes you. This might be my new calling, y'all. This might be my new calling. Oh, thanks, Swampy. I caught it after I looked over. I gotta. Anyway. It's finally getting cold in here. I had to turn the AC all the way down. Why is it so fucking? Was it so fucking hot? Oh, the sun just set. That's why. The sun hits this side of the building, and 99% of all the buildings in Puerto Rico are poured concrete. So, I mean, the good news is if a tsunami hits, we're fine. The bad news is it gets a little warm in here towards the afternoon through the evening. I'll switch over to a game in just a minute. I'm just bookmarking some stuff. I'm setting up a bookmarks folder for this business. I got a Confluent space set up, and I got a bunch of stuff documented.
close that, and close that, and close that. Do this until 1 a.m. This will be simulcast. Excuse me. I made those donuts today. The whole house smells like a Chinese restaurant. Just that vegetable oil smell. Okay, I think we can uncheck that. Make sure I don't have any PII up. I had to immediately stop the stream and delete everything because I basically showed a bunch of PII. But that's when the delay is a good thing, because if you do it like there's like after you stream for like an hour or two, there's a anywhere between like a 30 to like a 5-minute delay. Especially if you drop it like one to less than 1% of packets, it just kind of spreads the video out. And then you can actually stop the stream before those frames make it to the platform, and then you delete everything before it even gets done processing. You should be fine. So I'm not worried. I'm not too worried anybody even saw it. But yeah, my bad. I made donuts. I made dough, and then I put the dough in really hot vegetable oil. It's all in the main channel on the Discord. And that's stretching those calories, right? I bought 10 pounds of all-purpose flour. So if I take 2 eggs, 4 cups of flour, 1/4 a cup of sugar, and I got pound of sugar, and like 15. I got a big pack of eggs and everything. Anyway, making bread is like one of the easiest ways to have cheap calories. And I just need to start working out tomorrow. Okay. We close that. That was all the cover letters. That's the comfy UI thing Phoebus got me. That's staying up there. Okay, that's Patrollo Ward. It's not loading for some reason. Here it goes. Let me. What are we gonna do? There we go. I think we're just gonna play some more Scarbrand. I'm not. We'll get to Elden Ring this weekend. I do want to finish the game. But I do need some more skulls for the Skull Throne too. And then this weekend, Thug will be around. Maybe we can do some Dark Tide or some Space Marine 2. Thanks for hanging out, Swanty. Get some sleep. I'll see you during the vacation, huh? If that's what you want. Don't do anything you don't want to do on your vacation.
let me update the old Twitch. My ear's finally healed up. It's not, well, it's a little tender, so I still need to put the cushion on it, but I have no idea how I got that spot on my ear. It's like a little, this top layer of skin was missing, and then like a dumbass, I just kept wearing the headset. Oh, it doesn't hurt that bad. And then it got worse. There we go. Check, check. Okay. Now I can hear myself again without a delay, which is I'm really learning how to talk into the microphone and then hearing myself on a 3 or 4 second delay. But it's much preferable just to get the immediate feedback from this microphone setup. It also made me a much better singer because you turn the volume all the way up and you can actually hear what you sound like instead of what you think you sound like, because your voice is throwing the vibrations of your voice are throwing off the small bones in your ear, so you don't actually know what you sound like unless you hear yourself on a recording. That's why when everybody hears a recording of themselves, they're like, I don't sound like that. Like, yeah, you do. But I've just seen so much video of myself and so many recordings, like I know what I sound like now. And using this has helped me modulate my voice, not only for singing but for public speaking and things too. I need to practice working, using my bass voice a little bit more, talking from down here instead of talking from up here. Not much of a difference, but you might be able to tell. Okay, so I can't believe we got this army. These mechanics are bullshit. And I'm totally fine with it. Oh wait, no, they've thought of this. Yeah, I can't transfer units to him. I was like, there's no way I can do that. It's like they thought of that. They're like, no, you're not cheesing that, motherfucker. Let's think about this for a minute. I got a Herald of Khorne Lord, 4 regiments of Bloodletters, 4 regiments of Fleshhounds of Khorne, and two regiments of Furies of Khorne for sacking a village. That's why it's bullshit. It's fine. You have to admit it's bullshit. You have to. You can't not see this mechanic and not see it as bullshit. Has this guy played a lot in multiplayer? I bet this guy's played a lot in multiplayer because this is bullshit. Oh, and there's just a bunch of orcs all over the place. Oh, let's not piss off Settra though. Settra's not somebody I want to have on my bad side. Most of the hours that I have in Total Warhammer 2 is playing Tomb Kings. And wishing I could play as Nagash. Or wishing that Arcan could have a quest to resurrect Nagash. I know there's a mod out there. We'll probably mess around with it one of these days. Okay, so he's got a little bit of movement left. He's got movement left.
Oh, wait. Oh, no, because it happens at the end of the turn. So if I want to attack this turn, what do they got? Oh, they got damage. They got shit. There's not even any things with question marks. We're just gonna here. We're just gonna raise it. Occupy for 2,500. Oh, I already did it. Oh, do nothing. Okay. Well, then go into there. And now we can recruit more bloodletters. This is dumb. But yeah, look at our army upkeep. All right, we need to just hold off. Yeah, we just need to hold off. And then when we're actually in battle, we can summon 2 more units of bloodletters. Fuck this, man. This is funny. This is funny. This is funny to me. This is such bullshit. I love it. What's this? Bloodletting? Gain a bloodletting streak of 3 victories. Okay. What's bloodletting again? Deathforge. What's the bloodletting thing again? I just do blood for the blood god every chance I get. The barrier idols. What is that? Where is that? Show me. Oh, it's right there. Maintain control of the following provinces, either by direct ownership of the vassals. Okay, well, hold on a second here. Aren't we gonna... There's a chance that we're just gonna take control of this in the next 2 or 3 turns anyway. So I don't really need to do anything. I just gotta wait for that thing to proc. I think. What else do we got here? We're not ready to do that. There's 2 more turns before we can spend any more skulls on those buffs, so we just gotta keep going. What do we got over here? Okay, they got a decent sized garrison, but we got a double stack, so fuck them. Alright, we're gonna head over there next turn. What can he do? Oh, we can't replenish. We could... Oh, you can put them in combat trials and just farm skulls off of them too? But that's going to add to attrition, so I don't want to do that. Not yet anyway. Let's do this. Let's put them in March and send them this way. And then that way they're closer and we don't have to worry about anything. Alright, that's it. That's everybody. Scarbrand's doing his thing. Actually, can we go this way and then go into that stance? Oh, that's beautiful. You can. Yeah. Yeah, I'm just gonna let them heal up because they already got 2 bars. Okay, and then how are we doing on tech? Oh, that's right. We're headed for Warborn. So the moment, so between this, wait, we got something else. I think it's pillars. Yeah, it's that one. Recruit rank +1, and then when we get this research, we'll have recruit rank +2 for all those units. So that's very nice. We'll see what we'll figure out what we're going to research after that. Oh, they put them in gray when they don't have any movement left. That's interesting. That's good to know. That looks good. All right. Well, let me end the turns. Shut up. Let me update the. This is Scarbrand, right? Scarbrand, first playthrough. Blood for the blood god. Skulls for the skull throne. Oh, we got to capitalize skull throne. let's change that to Total Warhammer. Free, done. Okay, let me refresh the old Twitch page there. Make sure everything's working. Yeah, there we go. There we go. Alright, cool. Harvester of Skulls. Most sane mortals would flee rather than face Khornite might, but some suffer the affliction of pride. So it is that a green-skinned horde surges toward camp, their war boss loudly boasting, "These spiky gits ain't so tough." Unsurprisingly, the spiky gits prove tough indeed. The bounty is plentiful. Oh, great. So they just rolled up to camp looking for a fight, and we gave it to them. And claimed 88 more skulls for the Skull Throne. Got it. Mission issued. Unholy. Spread enough corn corruption to them. Oh, that's how it... Oh, I thought it was... okay, I get it now. Yeah. Yeah, that's this one, right? Yeah, we're getting there. We're getting there. So when we have 500... Okay, that's fine. Battle healing cap plus 15%. Ooh, what's that? Oh, and it gives regeneration too. What is this? It's an item, huh? It's a uncommon item? Okay.
The winds of magic are weak and fickle. Your power has dwindled. Be wary of
Khorne cares not for the winds of magic, okay? That's for the Zinchi boys. We don't care about the Zinchi boys. Now, why can't I move worth a damn? Is it because I started... Oh... No. Why can't I... Why is it... I don't understand. Why is it that I can't... What the fuck is going on here? Is it because I was in encampment stance? What if we raid? Alright, well, let's at least fucking raid. Hold on. Let me understand some... I'm missing some sort of mechanic here. Here, let me do it so you guys can see it. In total, Warhammer 3, I'm playing as Scarbrands. I just started a new turn. He was in encampment stance, and now his move radius is super small. Is that a mechanic of encampment stance, or is this a bug? It's actively meant to disable all campaign movement until you switch it off. Well, I fucking switched it off. This explains why his move radius is change from encampment stance movement. Remember, you need at least 50% of your movement pool to enter and exit encampment stance. So you just can't hop in and out. Some players pointed out, even with nerfs to his movement pool in early turns, you can still chain his special abilities and Bloodhost mechanics to get big movement spikes, even on turn 1, but that only works when he's in move-enabled stance. Reduced movement is not a bug, it's in camp stance where it is intended. Just switch stances. Okay, well, we did. And because we can't move far, we'll at least go to raiding. Let's get you out. Here, we're gonna keep these guys together. Here we go. Okay, so a little bit of income. Lord not moved. Well, he can't move at all. Like, well, it's just a lord. Can we attack him? Alright, so if we do nothing... See, I still have the same thing around. So, like, I don't know what's going on. Is it because he's in range? What if we swing on him? Oh, that's what it is. I'm super next to an enemy. That's fine. We're going to auto-resolve this because... Actually... No, it's fine. We're gonna auto resolve it. We're not gonna get. We can't. All right, so we may as well blood for the blood. Got it. Okay. Mission successful. Okay, we did it. Okay, and this time, oh my gosh, we get 5 turns before we start. Exalted. 1 unit. Oh, we got a soul grinder. Oh, okay. I finally get to see what that looks like. I've never seen this thing before. I didn't even know it was a thing. Flesh hounds, spawns, furies, a skull cannon, and a blood shrine. What's this? It's a magic chariot. Hold on. A blood-soaked rolling altar to the murder god's glory, bristling with fell blades, jagged spikes, and the shattered skulls of the fallen. Oh my gosh. What's the skull cannon? Demon-infused machine bombards anyone who escapes its wheels with their comrades' burning, screeching skulls. Is it like a chariot? Do you run people over with it too and shoot? What? How does that work? Deathforge, are you around? You're always around. I shouldn't ask that. Are you on call? Are you busy? Can you tell me about the skull cannon tactics, or do I need to look it up? Soul grinder. A fallen demon given new life of a sort with a colossal soul harvesting bulk. What's the story with this? Like, so I just got this new army, and it's got exalted bloodletters, a soul grinder, a skull cannon, and a blood shrine of corn, which I've never used before. My question is, the skull cannon, it's this demon-infused machine bombards any who escape its wheels with their comrades' burning, screeching skulls. So does this imply that you use it to like run bitches over too? Do you use it like a chariot? Is it like a chariot with artillery? Is that what this is? Best artillery in the game. Okay. Well, it certainly seems like it. Is that am I right? Do you run bitches down with it and like shoot at the same time? Is that, or do you shoot and then run people over with it? I don't know. All right, get out of that stance. Get over to their territory. Can you raid now? Not yet. We're not doing combat trials yet. Okay, let's put them in encampment. Don't they get a buff too? And then cycle charge with it. Okay. Alright, cool. Good to know. Very good to know. Okay.
I crave bloodshed.
It must be like tough terrain or something. I don't know why it's... Okay, and we just got him this turn. Alright, building upgrade available. Of mortal recruitment buildings. Upkeep minus 20%. Oh, that's reason enough to get it right there. Chance to automatically colonize ruin. Yes! Another 5% of that. Yes, we want that. Alright, what else are we getting? We don't need that right now. Income. Enables attrition in this region for enemy armies. Minus 15. Growth plus 20. That's growth, right? Okay, we don't need to double up on that because we're almost there. You must upgrade your main settlement chain first. Okay, well that's what we're doing, right? It's going from... Yeah, we're going from that to 2. Alright, so let's just hold on and we'll grab Gore Beast. Okay, we can start making those. Blood Shrine, Skull Cannon, Crushers. Okay, well, we'll do that. Well, what does this go up to? It only goes up to 3. Okay, so that's not for this province. Okay, get that. And I guess we'll take this, because then we can get that. What else? Minotaurs of Corn. Okay, we already got that. We can get Blood Reapers. We can't afford the upkeep right now, but we'll get one as soon as we can. You already fielding the current maximum number. Oh, it's right there. Okay. We could recruit another. We can't afford it. All right, we're just gonna wait. We're just gonna wait a turn. I don't need to overthink it. It's fucking turn 6. Don't overthink it next. Everything? Yep.
My lord, a rival power desires a change in your mutual relations.
Okay, yeah, you pay me a little bit more than that. But that's fine. Skaven are cool. We like them rat boys. He over here. Okay, cool. Well, friends, I like to be buddies with Skaven. Seems alright. I haven't ever played Skaven. I should play a game of Skaven too. We'll do it after this bullshit. Okay. Oh, we got it. We got it. It auto capped like we wanted it to. Okay, very good. Now what's the different here? A dimensional tear. So it's basically what I want to unlock in recruitment of. And then that'll unlock. Okay. Well, what? It's basically the same, ain't it? It's just one unit to the other. Corn corruption, corn corruption. Yeah, it's the same. The only difference is the type of unit you get to recruit. It even provides the same garrison. Okay. Well, let's go ahead and we got one of those. We got one of those. Let's go ahead and do this one again. Commandment available. That's right. What do we got? Growth plus 20. Upkeep minus 10. Recruitment cost minus 15. Ooh. But we're not there yet. We're not there. Control. Chance of spreading plague minus 40%. Corn corruption. Let's do that. We're waiting for this thing to get built before we build anything, so that's fine. Province secured, thank you. Drawn destruction. Yep. We got that. Mission issued. Issue commandment, we just did that. So we'll get it next turn. Let me go here and go here and look at him and details, and let's give him that armor. Okay, so now he's kind of decked out. Actually, no, take it off. Let's give him missile resistance. Yes, that's fine. 15 missile resistance for him is naughty. And then he's got... This is like the most useless thing because he's got... Well, I guess not. diplomatic relations plus 15 with Corn. Doesn't he have like minus 50 for starters? Where is it? Where is it? I could have sworn there was something where it was like he's the outcast. Whatever, it's fine. Let's keep going.
All the better to spill blood.
Okay.
These lands shall run red. Cardiff makes claim.
No. No.
Not here.
Let's go over there.
Slaughter.
March over here.
Sacred executioner. Corn's edict. Bring me body. Wait.
Okay.
Scourge. All mortal life. Corn slays a mind command.
I'll wait one more turn because then they'll have 2 experience bars. So let's just wait.
Must sate.
They don't heal up as much as I was expecting though.
May serve.
If I do this and this, oh, it won't let me do it. Okay. Yeah, it won't let me do it. All right. And the global recruitment's 1 turn. That's fine. Let's just keep no stance for now. I don't want to hinder my movement. Well, I only got... I might need those skulls. It's only 1,000. Income for post-battle loot plus 25. That seems good. Warcorn corruption. Let's use this when we have more things to capture, I think. I think we captured everything we can. Yeah. Okay. Yep, and we've already got Stormhenge, so yeah, let's do that. We'll do it next turn.
I am the wrathful reaper, but today I shall do no reaping.
Okay. Oh. Oh, he wants a non-aggression pact. I'm sorry. I'm sorry, we can't do that. You just happen to be the unfortunate person in my sights. Okay. Let's have you stop raiding.
Acceptable.
We don't want you winded when we do. Let's put you right there. Let's put you right there. And let's have you go there. Here. Continue the siege. You need to move a little bit more over this way. Post-battle dude. No, I'm gonna wait. I'm gonna wait. Okay. Now attack. Oh, we can't triple stack? Can't we triple stack? Oh, because that motherfucker marching. He's in marching stance still? Don't give me that shit. Who do we get? Hold on. Oh, it must be because he's in marching stance and he moved too much. That's okay. I won't be able to see the cool new units, but whatever. I'll cry about it. I do want to. I just want to see. I think what I'm going to do is just put Scarbrand in there. Let him do all the work. Can he fly? No, he doesn't fly. Oh, it's because his wings are broken. That's right. That's right. That's right.
I must. Throughout this land in a tide of blood, Khorne commands it.
He's taking 1,000 health off that gate every time he swings on it. It's only got 3,000 health left. Oh, there we go.
It's nice to have a legendary lord that's just really powerful in combat out of the gate. Like, this is great. Why, they can't, like, capture that? They got some experience. Let's save them.
Insufficient slaughter here. Exile revoked. Starbrand. We have given ground. Unacceptable. Army of the Dark Gods.
Okay, well that was annoying. Those harpies can't... Those harpies aren't good at taking the wall at all. I didn't mean for that to rhyme. Yeah, I lost more units than I needed to. Yeah, I lost those 2 units of harpies. Oh well. I thought, oh, they fly, but they can't. They can't capture shit, I guess. Probably because they don't want you just flying over the wall and then going to the cap point. That's probably it. I think we need more skulls, so we're going to do skulls for the Skull Throne. Oh, okay. Well, that's better armor. So let's have you put on the obsidian armor. And passive ability, melee attack, +4, leadership, +4. Okay.
let's do it. And then this guy, let's give him armor. Yup. And what skills you got? We increase mobility as much as we can. Missile resistance. Brass collar. Weapon strength, physical resistance seems good. Okay. Oh, it's this river we can't get over. We have to go that way.
We honor Khorne this day. Demons, go further!
What's over here? That's a necromancer. Was it orcs? Morgenheim. We got some undead there. Okay.
Blood crusade continue.
I guess we'll go this way.
This night.
Yeah, those are the guys we refused an alliance with because we're just gonna take their stuff.
Many demons dead, still triumph. I go.
Oh, and then there's attrition that way. Okay. Attrition from what? Vampiric corruption. Okay. Well, we'll just bum rush it next turn. So now we should be able to recruit units with 2 bars. Yep, there we go. Here, combine those. Ooh. Oh, we can't upgrade? We don't have the upgrade mechanic like the other Chaos folks do. That's fine. We got other bullshit mechanics. I'll actually take some of these guys. There we go. Alright, now what? Giant Slayer. Yeah, we just recruited a bunch of these guys, so we may as well get more armor for them. Then what? Charge bonus for bloodletters. Leadership for melee infantry. Melee for dual weapons. Okay. And then we also got to this. Ooh. We don't have any cavalry units that we can recruit yet, so... monstrous units, though. Now, what's this thing that we have to pay for? Oh, we got to get all those technologies first. Grants trophy killer banners. Penalties caused by terrain are ignored by this unit. Wow. Well, that'll make the hounds really good. Let's do that first. Bonus versus large. +8 for halberd infantry units. Okay. 10 for all chaos warriors. That's fine. And then are we missing? Oh, that's pretty good. That's pretty good. Campaign movement, right? All this is really good. We might start grabbing all of it next turn. Here, let's actually do that, I think. We will do that. We'll get the Giant Slayer because it's +10 armor. It's nuts. And then we'll move back and we'll get +10% loot, +5% chance for cap, +2% corn corruption, and then +10% movement range. So yeah, we'll just grab all that and then we'll figure something else out. All that stuff sounds super good. We got 5,000 skulls. We're almost ready for Unholy Manifestation. Let's go ahead and get +5 corn corruption because this will help the other thing. Okay, so that should help the Unholy Manifestation because it helps with corn corruption. Okay. Seems good. The top knots want a peace treaty? I don't think so. Here. Oh. It doesn't let you just... You just give me money. Okay, ward save +5. Yeah, there we go. Hit points replenished if cap not reached. Copycat killers. Recruitment cost -25%. Seems good. Capture 2 provinces. Okay. Okay. Recruit 30 units. Okay. Let's give him that talisman. And then here you can have this one. Okay, that's everything assigned. Okay.
The harbinger of doom. God's decree.
Okay, let's get both of you out. Okay. So if we move... No, no, give me the other one. Give me this one. Stand right there. Okay, now you stand like right here. Okay. Okay, good. Now you go right there. Perfect. There's the whole shebang. Close victory, he says. Alright, we finally get to see these crazy units. Scarbrand's gonna have to sit this one out. There's not a wall, is there? No, it's just a town. Okay. So it's town fighting. Look at the size of these trees, man. How big are those trees, bro? Each one of them trees is as big as Yggdrasil. Okay. Let's do this. Okay, let's see if they come this way.
My wrath is bound to less. Only Salota can sate it. Then all Salota.
Yep. 2 minutes. All my throwaway troops will be here, so we'll just wait you out. Oh, you coming?
I'm battle.
Oh yeah, heal yourself. Oh my gosh, oh, that's healing him. Oh, we can use him this battle. Oh, that's nuts. Oh my gosh, look at that. Is it going to heal him to full? 8, 7, 6, damn near. Holy crap, Scarbrand's back in the game. I was going to have him sit this one out. Never mind. Oh, we only get one use. Okay, you can't abuse the fuck out of it. Okay. Okay, any minute now, y'all. 38 seconds. Any minute. There we go. All right. Yeah, now you're upset that you waited.
Slay. Yes.
Okay, this is a little ridiculous. This is a little bit overkill. Now where's my cool units? Okay, there's the Blood Shrine. Okay, what is it? It's a chariot, okay. Magic chariot, got it. Now where's the Artie? Right here, okay. Oh, there he is. What is that? Oh, he's got like a mechanical body? Oh, that's funny. Wait, it looks like he belongs in Doom. It is. It's a mechanical body in fantasy. Well, that works because the warp is the warp. All right. Time doesn't mean shit in the warp. What is that? That's a wizard lord. Oh boy. And a feral flying manicore. Okay. What we got over here? We got our hounds. Let's put those hounds there. What else? Those guys are forming a line right there. What are these? Great sword infantry. Oh, they're more bloodletters. Okay. And then here's the special character. What else we got? This is a really easy way to learn how to play corn. That's just a buttload of blood letters. Okay. And then what does this thing do? Precursor missile weapon. The fire wills will with the precursor missile will only fire at target when they have been ordered to charge fire. Fire at will is enabled. The unit will fire at the closest enemy. Precursor missile weapon typically has low range and a small amount of ammunition. Okay, so don't turn it on. Army units can block damage from any source apart from armor piercing. Armor piercing. Fire while moving. It's a monster soul grinder of corn. Okay. And he's got a big ass flaming sword. Okay. Okay. Well, that seems fun. What are those? Harpies? Yeah. What's that? A giant. Okay. And then Axe infantry. And this is just some orcs. Dude, I wouldn't want to be these orcs right now. It's not cool, man. Attack them. And that's in case they try to do anything screwy. And then let's have fun with these two. These guys and these guys go this way. No. No, I want you to stay. No, the harpies will stay and defend him. Let's throw those things in there because they're dumb. Like in a good way. And then we got tons of harpies. Let's have the harpies fly over here. And then there's, what is that? That's all blood letters and an exalted. Okay. So why don't you just form a line right there? This is a lot of units. This is funny. Okay. All right, let's see this this artillery in action. Alright, how's that soul grinder holding up? Oh, you can't do shit. There's the already going. Awesome. Oh, now he's got the anti-large, but that's okay because here comes the chariot. Ride him down. Okay, go attack them. That's funny. Wow. Okay, he's actually dealing with a threat, so these guys can get there really quick. Let's do that. You and you go there. You and you go there. And then get in there. Get in there. Where are these hounds? Right there. Get in there. All these guys are expendable. All right, battle starts. Almost out of ammo. Oh, come on. He got that debuff on him.
Massacre shall not end! Chaos Warriors of Khorne! For the Dark Dogs!
Everybody kill that giant.
Boxing! I will! Focus on the fury! Kill for Khorne!
Oh. Stop targeting shit. We're using everything? No, we got a couple units back here still. Just head there.
Hordes of chaos! Taker of skulls! Mercy! Zoro! Rip and tear! Annihilate!
They're so stacked up on top of each other, it's ridiculous. This is disgusting.
For the dark gods! The defenders are slain. Towards the train!
That's what I thought. No sub sound, slacker. Oh wait. Wait. No, Raz. The Phoebus is working on it. That's one of the things Phoebus is working on. We're going to use his bot. We're not going to use a bot that's already out there. Phoebus is deliberately coding up a bot, an AI bot for me to interact with. But thank you for the sub. We'll have that up there soon, I promise. Or Phoebus promises. Okay. Why not? Mount Gain Juggernaut. Oh my gosh. Oh, they're not even taking attrition anymore. Oh wait, yes they are. What do we do? Okay, encampment stops the attrition. So go this way. Encamp, no attrition. You're here. Go to encamp, no attrition. You can't move anymore. Go to encamp, no attrition. And you do it. And there we go. We just solved the attrition problem. Until next turn when we move over here. Okay. What can we get here? That seems good. Let's do that. What is this? Ten skulls per turn. Sure. Income from post-battle, do it. Let's do that. Let's enable attrition. There. There's that. Okay, we're building everything up. Then we need to level up Scarbrand. So we got 2 points. Okay, so we got this. Now we're going for this. We're just going to make him an even bigger beast. More weapon strength. And then he's riding a Juggernaut now. That's dumb. I mean, in a good way. Spell resistance. Charge bonus, base weapon damage, armor piercing damage. Let's do that because he's on a Hungering Blades. That's a passive? Oh my gosh. What else? Oh, that's if we want to. He's gonna fight with them because I'm using him to give mobility. Okay, so you get an ability. Let's use that because we're gonna get him into the shit. Okay, and then we can grab one of these too. Melee attack plus 40 in an area. Yeah, those two seem really dumb together. Okay, let's do that. Okay. No, that's a good point, Raz. What do you suggest? I was looking at Streamlabs, but they want money. What's I guess Nightbot? Zeech Ascendant, okay.
Lord, we have brokered an alliance with your brothers. They lie in wait as the enemy approach the brazen altar. All it requires is your attendance.
Okay. Okay, so we need to bring some anti-large. Okay. Oh, no, not yet, not yet. Move first, and because I don't want attrition, you can just stay in that stance. There we go. And let's get the Flesh Hounds. Let's get one Harpy and two of the Flesh Hounds. Let's get another Harpy. It's got a lower upkeep. Okay. Okay, we're just moving the Zerg Ball. Okay. We'll spin some skulls. Okay, we got 3,000. We're negative upkeep. That's not good. Okay. Oh, you can't cross that river? What's going on here? Okay, you can pass it. Can't you? There we go. Okay, so you'll take a little attrition, big deal. Get across it, there we go. Oh, movement here sucks. There we go. Oh, wait a sec. Let's do this. There you go. Get across it. March. Get across it. There we go. March.
Don't stop. Suck blood first.
Can we do this? Eternal War. Summon a small hostile army to attack the target immediately. Okay. Let's hang on to that though. An army must be selected. There we go. Okay, I'm gonna hang on to that and do it when I need it. Post-battle loot. Let's do that. We need the loot. Oh, okay, yeah, we could probably make one. We gotta do that next week. Let me put, I'll do that tomorrow, I'm tired. Set up chatbot for notification of subs. Find free version. Set up Doom 2016-ish style music / notification when someone subs. Okay. We'll get it done tomorrow. More tech. Let's go back to here. I was just gonna get, yeah, this one. Automatically colonize ruins. Yep. Plus 5% of that seems good. Alright. What do you got? Okay, you don't need that anymore.
Sacred Executioner!
You're in no stance at all, are you? Yep, no stance at all. Stand right there. You...
Acceptable. Spread slaughter.
Move over here.
I crave bloodshed. Slaughter. Search.
Move right there. You vampire counts. Bunch of skelly boys. It's no contest. It's no contest. Go ahead and auto-resolve that. And we need skulls for the Skull Throne. Slaughter. Yep. Make him more of a badass.
So much murder. Rejoice.
So you can move here and then go to encamp, and you won't take attrition. Same thing with you.
Replenish. God's chosen.
Nope.
Greatest bloodletter. Replenish.
Or no, wait.
Corn triumphs. Enemy slaughtered.
Alright, let's leave it and see what happens. Upgrade that. More income from loot. These mechanics are pretty crazy. Scarbrand's beefy. Okay, so you should be able to move. Who's this? Blood Reaper.
The
Oh, okay.
sites of recent battles may bear many fresh prizes to adorn the Skull Throne. Send your minions to search these places, for the blood god's skull hunger is insatiable.
Okay, what's he doing? Oh, he just got put over here. Okay. Well, let's move you over this way. Go do something up there. How about you? So if we move you over here, you won't take attrition anymore because of the vampiric corruption. There we go. How about you? Get over here. You don't need corruption anymore. Got it.
It shall be.
You can march this way, you're not in attrition. And if you march, you can make it over here, you won't be in attrition either. Okay, good. We solved that attrition problem. That was kind of a pain in the ass. Now, can Scarbrand... Okay, we can't raid with him. Who else is an encampment? Here, move all the way over here. There we go.
I hunger for battle.
You can't move. You can't. You've moved as far as you can. Okay. Notification. Could have a message. Another brother joins the chapter. Put it next to this or something like that. You know, something 40K-ish. Okay, good idea. Very good idea. Wrote it down because it was a good idea. When I have or get good ideas, or hear them, I write them down. Okay, good. Yep, 10% for blood host seems good. Okay. Okay, what's that? That's some Skaven. Are we? We have a non-aggression pack. Okay. Non-aggression, that's fine. Assault the garrison, sure, why not? Failure. Alright. Actually, what happens if you raid? Nothing. Move up this way. Come out of that stance. Move over there. Come out of that stance. Move that way. It's like we're just moving the Zerg ball. Okay, we take that next turn. Then what we got? We got some orcs over here. Yeah. Orcs and goblins. Let's have you move like... Not you. Move that way so we can start scouting. We'll use him to scout. Okay, we got to do something about the income here. Skarbrand is ridiculous. He's absolutely ridiculous. There's this massive Zerg ball. What do these guys want? Oh, they don't want me to take their stuff. We're at war. No peace. No peace. Recruit an additional lord. Okay, as soon as we fix our economy.
I refuse. Want pray.
Okay.
Skulls. Wait. Horn commands it. Old Volta will die.
Okay, these guys start taking attrition next turn, but that's fine. We're bottlenecked. We're bottlenecked right there. Oh wow. Building upgrade, we can't afford it. Okay, we gotta get... We're gonna start raiding or something. Actually...
Blood for the blood god.
I'll get rid of them when I have to. Yes, I know all about this.
Your skull belongs on the skull throne.
He wants peace too. I'm sorry, I can't do that.
I'll have your soul.
Oh, we screwed up.
Murder. Seize all they have.
No.
Bathe in fury. Be renewed.
Okay.
It fuels
Yeah, we screwed that up. We should have sacked that first. Shit. All right. Okay, I get it. I get it. I get it. Let's save the game. I'm gonna get annoyed. I was off to a great start and I screwed everything up economy-wise and attrition. Now we're in an. I should have gone a different direction. I'm not in a good spot anymore. Exit the windows. We saved it. Yeah. Okay, cool. Let me go get something to drink. Do a quick bio. We'll probably switch over to Helldivers 2 because it's just mindless fun. I'm getting a little too tired to. It's getting late, and I'm gonna be in. We're ending the stream at 1 tonight, so in 2 hours. I'm not gonna stay up until 2-3 o'clock in the morning like the last 2 or 3 nights. I gotta get to bed earlier. So we're gonna hang out for another 2 hours. Let me take a quick bio. See about dinner. Start heating something up, and I'll be right back. Okay, give me 5. Everybody, just take 5. And then thanks for the suggestions, Raz. That's a good. You got some good ideas, man. We'll see what we can do about it tomorrow when I'm not super tired. Otherwise, I dive into it right now because I want to. In fact, it's a good idea for me to get associated or familiar with one of those bots so I can give Phoebus feedback on how it is to set up an OBS and the features that it offers and all that kind of stuff. So it's actually a really good idea that I at least try one of the free things. So good on you, and thank you for suggesting it. All right. Custom bio break. 5 minutes. Maybe yeah, I'm gonna see about dinner. I ain't gonna eat just yet, but let me see about dinner. Okay, cool. Let's do that. I'll be right back. See if he gets it. Hey, are you back home? Are you hungry, or did you get food on the way back? I'm gonna heat something up in about an hour. Okay. Okay, it's time. It's time to serve Super Earth. And let me change the. Let's see here. There we go. Helldivers. Let me update the old. There we go. Helldivers 2. For managed democracy and Super Earth. Solo.
Super Earth. Our home.
Random solo queues.
Prosperity. Liberty. Hi there. Democracy. Our way of life. Oh, hello. But freedom doesn't come free. No! Sweet liberty! No!
Okay.
Look familiar?
Issued by Ministry of Prosperity. Ooh. Let's equip that. Oh, it looks so cool. Oh, you got Helldivers too? Yeah, let's do it. Don't I have here? Let me sign on. Do I have you on? There you are. There we go. I guess I could send it. There you are. There you is.
Helldiver, the Super Destroyer is ready for your next mission.
Did you get the invite? No, I'm happy to have you. You know, you wanna play a couple games together? I'm happy to have you. You misclicked? I sent it again. I sent it in game. You might be able to join on me. There you are. Oh wait, hold on. Let me salute an officer.
And you're marching in place. How do you get that? I want to march in place. Oh, there we go. Alright, let's do it.
You get it through all of each other.
You unlock it when you do everything? Okay. So, Terminids. Evacuate cities. Evacuate high value assets. Alright, we got 2 bug missions coming up.
Initiating FTL jump to the Alta system. FTL jump successful. Mission coordinates locked. Hellpods primed.
Okay. How about right here? All right, I want to take this machine gun because I like it for the bugs. Yeah, we got to take the laser. You're gonna take the napalm? Okay, I'll let you take the napalm. I'll take this and the laser and then a Gatling turret. Let's get the stamina. Yeah, we use that. We use the bombs to.
Hellpod launch initiated.
Ooh, it's raining. Maybe mute me on stream, and I'll chat to you in game.
Requesting advanced weaponry. Dropping a pin.
Okay.
Tactical asset nearby.
All right.
Engaging terminal.
It stopped rain. Stopped raining. Yeah, go to the, yeah, there you go. You're going the right way. You're almost there. Keep going. There it is.
I got the terminal. Liberty dispensed. Tagging map. Northwest. 200 meters. Sending in an eagle. Marking location. Southwest. Sub-objective nearby. Orbital inbound. Objective critical stratagem available. Calling down objective equipment. Sample collected. Package acquired. Dropping package. Package acquired. Dropping package. You man! I got the terminal. Say hello to democracy. Bugs, south.
All right, now what?
Dropping a pin. Tagging map. Requesting orbital. Their lines were in ours.
Oh!
Tell that never die. Say hello to democracy. Fire in the hole. Rear sample acquired. Requesting sentry. Bug outpost spotted. Prepare to exterminate. Enemy tactical asset within range.
Get out of here. Don't be near me. Just run the opposite direction from where I'm at. There we go. All right, did that do it? Damn, there's still more?
I'll get it, don't worry.
Oh shit. Alright, that's it. I'm gonna call in some supplies. Oh, you already did the resupply? I gotta find some ammo. Oh, did I hit you? Or did you die? Oh shit.
Reinforcing.
That wasn't me, was it? Did I shoot you?
Tagging map.
What else is left? Is there still... Are there still bug holes around here?
Throwing supply beacon. Bug hole, northwest, close.
Oh, it's up there. That's right where... That's right where I need... Okay. Right where I need that landed that ammo. Oh, it fell on top of me. Oh, it fell on top of me. Oh well. Oh man. That was a quick reinforce, thank you.
Ready to liberate.
Okay, well I don't need that ammo anymore, so...
Rare sample acquired. Calling down a support weapon. Tagging map, southeast, 50 meters. Requesting air support.
I wouldn't get too close.
Dropping a pin. Requesting air support.
You got it? Yeah. I gotta remember my push to talk key's different here.
Tagging map. Sending in an eagle.
You got it. Oh, I got it.
New mag.
Very nice.
Dropping a pin. Northwest. 100 meters. New mag. Got a sample.
Main objective nearby.
Calling down a sentry. Objective located. Orbital inbound. Calling down supply. Engaging terminal.
E3.
Get some! Get some!
Wow, your napalm's still getting them. I'll keep an eye out for the bugs. Just, yeah, release those. I'll let you release them. I think we're okay. Yeah, they're coming up here to go.
Sample collected.
They're walking up all the way where I'm at anyway, so I'm in a good spot. If I die, pick up all my samples. I got a buttload of samples on me. 50 seconds on Gatling Sentry. I don't want to jinx it, but I think we're doing good. Just keep sending them. My Sentry's still up too. We're in a good spot. I'm gonna have to up the difficulty. It's not on extreme, it's on hard. This is a good warm-up. One more. One more. Oh, there we go.
Another step towards galactic liberation. You may extract when ready.
let's get out of here. Collect all of our fat rewards.
Got a sample.
You're doing the march salute. Is that the 500 kilogram bomb?
How'd you like the taste of freedom?
Yeah, it was.
I'm surprised it didn't knock us down.
Tagging location. South. Cancel that. Throwing grenade.
Oh shit. I'm going to the wrong one.
Mag's empty. New mag. Have a taste of democracy. New mag. Last reload.
I'll call in a Gatling as soon as we get up here.
Requesting sentry. Calling in extraction. Throwing supply beacon. That's called democracy. New mag. Sending in an eagle. Reloading.
Ha, you're gonna nuke them.
ETA T-minus 30 seconds.
Is that the grenade launcher?
No, it's automatic shotgun.
I'm going to switch my keys around. I don't know why I have this key set up. Oh, because I was in a hurry to set a push to talk key.
God damn it, 1 kill off.
Okay.
Lots of enemies killed, lots of samples collected. That's a good mission in my book.
Okay. Or give me a sec. Let me switch these keys around. Movement. Vehicle. Oh, combat? There it is. Quick stem. F1. Okay, and then communication. Open comms wheel. Okay, that's better. That's what I'm used to. I had the stem key was the V was the default for the stems on the keyboard. All right, let's figure it out.
Engaging orbital thrusters. Orbit synchronized.
Yeah, I should take that laser instead of the guard dog.
I'm going to do minor damage reduction instead of stamina because we ain't going very far.
Hellpod launch initiated.
Do me a favor, don't close the gate down here, the last one.
Okay. I don't... What are we... Is that where they're going to be coming from? Should I put the sentries up here or over where you are? Here, I'll put a sentry over here.
Calling down a sentry.
Oh, it bounced.
Sending down sentry.
Okay, I'll put one right there.
Requesting sentry.
Okay. Oh, this is where we shoot the missile. Okay. What else do... Oh, it's a timer. Okay, we're counting down. Okay, got it. Okay, I'm going to drop this explosive barrel over here.
Requesting orbital.
Engaging orbital laser.
Tagging location.
Ignore that.
Marking location.
Our citizens depend on you for their safety.
Tagging location. Cancel that. Heavy. Requesting sentry. Calling down a sentry.
Deploying sentry.
Calling down a sentry. You will never destroy our way of life. Get some! Get some! Bugs, southeast. How'd you like the taste of freedom? sentry! That's called democracy! Requesting sentry! Say hello to democracy! Throwing grenade! Going down a sentry! Calling down a sentry! Requesting sentry!
Sweet mother of freedom. Look at him go!
Bugs, southeast. Orbital inbound!
Engaging orbital laser.
Supplies. Have a taste of democracy! Calling down a sentry! Requesting advanced weaponry! Throwing supply beacon!
I killed myself with my own turret.
Request approved. Reinforcements on the way.
Point me to the enemy. Heavy, northeast, close.
Oh, your spot's way better.
Requesting sentry. Requesting sentry.
Sending down sentry.
Reloading. That's called democracy. Get some. Get some.
You can't close those with a grenade, can you?
Nope. Can't close. Is that all you got?
Mission at 10 minutes remaining.
Going down a sentry. Fire in the hole! Throwing grenade! Get some! Get some! Who's still with us? Requesting sentry. Requesting sentry.
Oh, I destroyed my own turret.
Calling down a sentry.
You have served democracy well. Extraction awaits.
Dropping a pin. Southeast. Close.
This is Post 1. I have visual on the extraction zone.
Requesting sentry. Requesting orbital.
Firing orbital laser.
That's too cool.
Countdown initiated. Stand by for takeoff.
Reinforcement budget depleted.
Run, Nick.
Oh,
Run.
shit!
Go for it.
Countdown complete.
Yeah!
You leave a more free city than you.
Nailed it.
It wasn't an accident. It was completely timed.
Do you need to do one more of these to get the bonus? Oh, you don't really care. You got all the stuff already.
We already got this.
Mission accomplished.
Yeah, that machine gun is just so good for those bugs. That's funny.
Your fellow Helldivers rage against the enemy's tyranny. Join them.
I'm gonna up it, and then I'm gonna hit quick play, because that's the true Helldive.
Choose any of the available operations, Helldiver. Each one you complete.
Initiating FTL Jump 2.
What the hell?
Jump complete. Mission coordinates locked. Hellpods prime.
Get out of there, son.
Running. Oh shit, where'd he come from? Get out of there. Okay. God damn it.
Show these alien invaders no mercy. Joining the fray. Requesting tac pack. Calling down support weapons.
Oh, it's one or the other.
We've got equipment.
Somebody grab this tac pack. I mean, if you can use it. I didn't realize you can't carry two.
Tagging map. Northwest. Far. Dropping a pin. West. 300 meters. Back empty. Requesting air support.
Warning, you are in range of enemy artillery. Warning, you are in range of enemy artillery.
Orbital inbound.
like I found the fish.
Southeast. On my position. I'm on the terminal. Sending in an eagle.
Warning, you are in range of enemy artillery.
Come on, fuck's sake, man.
Calling in reinforcements.
Warning, you are in range of enemy artillery. Request approved. Reinforcements have been launched.
I'm on it. I got the terminal.
I hate dying.
Requesting air support.
Could somebody throw my request on my body, please?
I don't know where you died, bro.
I think they might be right where I'm at.
You guys got him? No. Alright, good.
All good, bud. Thank you.
Oh, come on. I don't know whose weapon this is. Looks good though. Jesus Christ, get off of me.
Reloading.
Somebody take my shiz. Where's my stuff?
I might have your shit, dude. It's this weird gun with the yellow tip on it.
Uh-huh.
Yeah, I got it, bro. I thought it was my shit.
Support weapon.
Where are you? I'm coming. Can I drop this shit?
Marking location.
I'm at the LiDAR right now.
You can keep it, buddy.
Alright.
Dropping a pin. North. 300 meters.
One step closer to mission completion.
Come on.
Dropping a pin. North. Far. Requesting air support. Heavy. Northeast. 100 meters. Calling down supplies.
Sending down equipment package.
supplies.
Going the wrong damn way.
Enemy patrol, northwest. Bots, north. Sending in an eagle! Requesting orbital.
Firing orbital laser.
Supplies. Objective located, north. Injury? What injury? How would you like to taste of freedom? West.
Really, dude? Really? Oh, dude, I didn't even see you there, man. Fuck, man.
We can't spawn you back in, bro. The jammer.
Hold on, I'm leaving the area.
Reloading!
There we go.
Reinforcing!
You can't throw it back into the zone, it won't work. Oh, what? Yes, dude. No mind.
And if you were asking me why I couldn't, yeah, I'm not going to. Sorry, buddy. I'm too locked in. Hey, I'm just being honest, okay? He was asking a question. I was answering the question.
Not a big deal, bro.
Reloading! Fire in the hole! Engaging terminal. Bots, southeast. Heavy, southeast. Close.
Objective critical stratagem available.
Oh shit.
I got the terminal! To the sky!
The hell bomb's on the other side of this thing. Arming up. Yep. Running.
Can't liberate
Get the fuck out of here.
broken arm!
Control out east, southeast.
Rolling supply beacon.
Ah, bro. Out west.
Requesting air support.
That moment when you forget to reload your cartons.
Mission at 20 minutes remaining.
Dropping a pin. South. 50 meters. Heavy. East. 50 meters. Sending in an
Oh shit.
Good shit.
Orbital inbound.
You got it?
How do we do this?
I'm gonna throw a grenade in there.
Oh, you throw a grenade in there when it opens up? Okay.
Come on, damn it.
Throwing grenade.
Nope, not enough. There we go.
Outpost destroyed.
Oh, that was... Okay, that's how you do that.
Where to next?
Tagging
First side
map.
of the map.
Northeast. 200 meters.
There we go.
Tagging location. Tagging map. West. 200 meters.
You hear that, right?
Yeah, I hear it.
Drop something up there.
It's like in the ground.
Walker.
That's a beautiful goddamn horizon.
Requesting air support.
Engaging orbital laser.
2 tanks out there.
Sending in an eagle. Requesting advanced weaponry. Box east. Dropping a pin east. 300 meters. Requesting air support. East. 300 meters. Heavy, southeast, 50 meters. Bots, east. Marking location, northeast. Heavy, east, close.
Jesus, how many heavies are there? He's still up? No, he's dead, right? I thought that meant so. How's it going up there?
We're all set. Launch sequence initiated.
Gotta fix this Liberty-forsaken arm! Dropping a pin. Mag's empty! Requesting air support! Mag's empty! Bot outpost! Sending in an eagle! I got the terminal! Tech pack inbound!
Deploying equipment package.
Requesting orbital!
Outpost destroyed.
Dropping a pin.
Launch in 8, 7, 6, 5.
Freedom marches onward. Thanks to you. You may proceed to extraction. Tagging map. South. 300 meters.
Thank you. Yup.
Sweet liberty, my leg!
That dude just tried to suicide bomb me. Yeah. Oh. Great. Get Hulk over here.
Throwing supply beacon.
Oh, thank God.
Oh shit.
Requesting air support.
We already cleared this, didn't we? Yep.
Drop ship.
Can we call it in? Looks like you're yeah, you're fine.
Calling in extraction.
Yeah, I mean, we don't gotta go in.
Extraction request confirmed. Shuttle inbound.
Keep moving next. Keep moving. I think there's a bunker down here. You guys are looking for gunship bunker. Let me go check it out. Maybe it's not a bunker. Oh.
Requesting advanced weaponry.
Oh, it's one of those. All right.
New mag!
ETA T-minus 1 minute.
Sending in an eagle! Reloading!
ETA T-minus 30 seconds. ETA T-minus 20 seconds.
Sending in an eagle! Charging in an eagle! Orbital inbound! Orbital inbound!
You all ready? You want to hang out here longer? I'm good.
Let's get
Let's
going.
Get the fuck out of here.
Let's get on out of here, boy.
20 seconds.
I'm done, gentlemen. It was a good game. Thank you.
Hey, good game. Raz, I'm gonna take off too, man. I'm gonna get something to eat.
Always
I
good
got
to
the
have
worst
another hero
deaths.
on board. Mission accomplished, Hell.
There we go. Okay, that was a lot of fun, guys. I'm going to bed. I'm getting ready for bed, basically. I'm gonna eat some dinner. And then I'm just gonna take it easy before bed. I'm not gonna get a big adrenaline rush from Helldivers 2 right before I gotta go to bed. And then this way we'll start the live stream a lot earlier because I got a couple people over in Europe going like, "Hey, why are you starting the stream so late?" So we'll see if I can't get started around 9 a.m. Let's see, it's gonna be Saturday, isn't it? It is, yeah, it's Saturday, so probably won't see Phoebus for a while. He'll be sleeping in like he should. And then yeah, so if I start at like noon, yeah, I'll focus. We'll do. I got some work stuff to do, but we'll check out another documentary or something while I'm just reading through my book and taking notes about setting up the business, which is really important. I really need to start making some revenue. So I think with my skill set and my roommate's skill set, we shouldn't have a problem. Because I can certainly set up a bunch of workflow pipelines and get the website running and all that kind of stuff. And yeah, I can't wait till we start doing that. Well, thanks to everybody for hanging out. Hi to you folks that are watching from home, or excuse me, not watching at home. Watching while this is offline. I know there's a few of you out there, so hi. I see you. Take it easy.